సేమ్ లింక్ కదా? సేమ్ లింక్. Okay, so we'll start the class. Yesterday we were left with, so we've finished biotechnology as such. We'll start with, just give me a second. We'll start with energy, space, and other topics, defense. So firstly, the news was India's renewable energy capacity hits new milestone. So renewable energy now constitutes roughly around 46% of total capacity. So this is something which is important because our Panchamrit was, our aim in Panchamrit, which was given at Glasgow COP26, was to have to ensure two targets. First is 50% of our energy requirements, or sorry, not requirements, 50% of our energy installed capacity should be from renewable sources by 2030. Now, in 24 itself, it's 46%. So we are almost there. This is something important. By 2030, 50% by renewable energy. The other target under Panchamrit is 500 gigawatts from non-fossil fuels. Okay, so we have to achieve the capacity of 500 gigawatts from non-fossil fuels. Currently, how much is our total installed capacity? Roughly hovers around 450 gigawatts. So you see, we are saying that we should have 500 gigawatts of what do you call energy from non-fossil fuels only. This is very huge. Our total capacity today only is 450. Okay, we are saying by 2030, 500 gigawatts we'll get it from non-fossil fuel sources. That means hydro is something which we are looking at to increase. Okay, then and the target of nuclear energy is to have 100 gigawatts by 2047, which was announced in this budget. But the previous target, which was given in Kunming Montreal Protocol in COP16, was to have COP16 or 15 COP15 of CBD, was to triple our nuclear energy capacity. Okay, currently we stand around 8.1 gigawatts. So these numbers are important because we're aiming to triple it by 2032. Okay, we're aiming to triple it. That is to have 22.48 gigawatts. Current number is important. 8.1 gigawatts is something our nuclear energy capacity. Okay, now moving on. According to Central Electricity Authority, the total renewable energy based electricity is currently 203. Okay, so that means this is 46%. That means roughly we have 450 as our total installed capacity, including coal, etc. Yeah. Now, which states? Which states have a lot of renewable energy capacity? First is Rajasthan. Now, when I say renewable energy, it's both solar and wind together. Okay. So Rajasthan has highest renewable energy capacity. Gujarat is not far behind. Then you have Tamil Nadu, then you have Karnataka. Okay. So Rajasthan first, then you have Gujarat, Tamil Nadu, Karnataka. Rajasthan, Gujarat, Tamil Nadu, Karnataka. Tamil Nadu has high wind energy. Okay. Now, this is something you have to know. Two northern states, two southern states. Tamil Nadu, Karnataka, Rajasthan, Gujarat. This is for coal capacity. See, now which state has highest, states with highest coal capacity, then renewable capacity, then hydro capacity. Coal capacity in the sense highest power in terms of what do you call coal generating thermal power plants. Okay, so just know UP has highest coal capacity. That's it. Only one state, if you know, it's enough for coal capacity. UP is highest. Then for renewable energy, it's again Rajasthan, Gujarat, Tamil Nadu, Karnataka. Then fifth is Maharashtra. Fifth is Maharashtra. Just know that. Then for hydroelectricity, first is Himachal Pradesh. Okay. First is Himachal Pradesh, then Uttarakhand. First is Himachal Pradesh, then Uttarakhand. Later, you see Karnataka comes. Immediately Karnataka comes. Okay. Okay. This is again Karnataka. Where did we see Karnataka? Fourth in terms of solar, right? Fourth in terms of solar. Third in terms of hydro. Fourth in terms of solar. Third in terms of hydro. Yeah. So quickly to revise: wind, wind nine. This is solar, the total renewable. First, let's get with total renewable, and then hydro. Renewable first is Rajasthan, then Gujarat, then Tamil Nadu, then Karnataka, then Maharashtra. Hydro first Himachal Pradesh, Uttarakhand, third Karnataka. Okay, that's it. Three are enough here. You see our installed capacity. Coal installed capacity is 218, roughly 220. Okay, then when it comes to nuclear, it is 8.18. 8.18. Now, what is the target? To make it 100 gigawatts by 2047. In this budget, 20,000 crores were given to make 5 small modular reactors. Okay, we'll discuss what is a small modular reactor. But our budget 20 gives us key. We have to have 20,000 crores are given to make at least 5 small modular reactors. Now, where are we trying to get this technology from? Largely France, because small modular reactors, I mean, with respect to nuclear capacity or nuclear energy, France is a front runner. Okay. So again, this in last decade we almost doubled, right? Then yeah. Now, firstly, what are small modular reactors? Small modular reactors are advanced nuclear reactors with power generation capacity of 30 megawatts to 300 plus megawatts. Okay. In general, a big reactor starts with 700 megawatts or let's say 500 megawatts. Okay. These are big nuclear reactors. Small nuclear reactors start from 30 to 300. Okay. Now, this provides a flexible, scalable, and cost-effective alternative to conventional large nuclear reactors. For example, if you have a small nuclear reactor, you can use that one to power an entire island nation also. Okay, so it's very flexible and versatile. But the problem with that is they are held as nuclear backpacks. No, but when it comes to melting of the core, that doesn't happen in small modular reactors. Okay. Closed fuel cycle. Closed fuel cycle being a cornerstone of Indian nuclear power program, country's first prototype of fast breeder reactor achieved a milestone in 2024. Okay, so we have our first fast breeder nuclear reactor, which is in Kalpakkam. So we have achieved some significant milestones in that. We have achieved many milestones. For example, primary sodium filling. So what happens in these fast breeder reactors is that sodium is the coolant. Sodium is the coolant. And since sodium is the coolant, the problem with sodium is it's highly reactive. It corrodes the pipes, and it's highly what do you call? If you pack it into a pipe, it can be a little explosive also sometimes. So that's why this is a achievement, because we have primary sodium filling was done in the main vessel, and purification of filled sodium and commissioning of all 4 sodium pumps were there. So that is a huge thing, because we once the coolant is ready, the technology can be ensured, because theoretically we have a sound what do you call theory regarding our 3-stage nuclear fuel. Second stage is powered by plutonium fast breeder reactors. Okay, then yeah, India's abundant thorium reserves, which constitute 21% of the global total. So just know 1/5 of world's thorium reserves are in India. 1/5 of world's thorium reserves are in India. All right. And this is our energy capacity mix. See, 47% today is only installed capacity. Okay. So 47% is coal. Then after coal, immediately you look at hydro. Of course, after solar, coal, solar, wind, hydro. This is the order: coal, solar, wind, hydro. But this together, you see 21.18, 40. This is 31.31, and you add all of the small hydro. Then you had this big hydro also. There's another 10%, 10, 10, 20, 21 here. You add them up, and biopower also, it will be 46%. 46% will be from renewable sources. Okay. So just know that after coal, it's immediately solar. After solar, it is wind and only hydro, later hydro. Okay. So hydro is fourth. Hydro is fourth. Then only 1.77% nuclear. So it's still less than 2%. If the question gives 5%, it's wrong. It's wrong. Okay. It's a wrong statement. Now, when it comes to energy, there has been a latest discovery, new discovery of oldest uranium mine of India in Jaduguda. Jaduguda is in Jharkhand. It is the oldest uranium mine. And in that oldest uranium mine, we had a new discovery. Now, the discovery is so much so that for next 50 years, we have enough uranium source from there. Okay. So the new discovery happened in Jaduguda mines. Old mine, but again, a new deposit was discovered. Energy. So firstly, in 2024 only, we had a all-time maximum power demand. So 250 gigawatts was demanded at a time. Okay, that is all-time maximum power demand. Then per capita electricity consumption. This has increased. Currently, we have per capita electricity consumption of roughly 1395. Now, do you have to remember the number? No. But you have to know that it is roughly around 1400 kilowatts. Okay, the per capita electricity consumption is around 1400 kilowatts. Okay. And in nuclear, yeah. So we have first 2 indigenous units at Kakrapur. Firstly, just give me a second. Didn't I upload PDF? Yesterday's PDF was uploaded, right? Okay. I'll upload it after the class. I'll upload it after the class. So with respect to nuclear power, this year, nuclear power is completely in the news. So they can ask you anything about nuclear power. So you have to first know that we have only few indigenous land. That means until now, whatever the nuclear reactors we built with some other countries' help, or some other countries, what do you call, old equipment or some equipment which we imported a lot. But the indigenous design and development has been done for the first time. So the first 2 indigenous units of a pressurized heavy water reactor at Kakrapur. Kakrapur is in Gujarat. Okay, they started commercial operations. Okay, so first 2 indigenous units at Kakrapur have started commercial operations, and the third indigenous pressurized heavy water reactor, which is at Rawatbad, Rajasthan, it has reached criticality. Now it has only reached criticality. It has not started generating power, but this has started generating power also. Okay, this will soon generate power. Now these three are first among the 16 sanctioned indigenous reactors. Okay, there have been 16 sanctioned reactors. So first two ekkada vachinayi, Kakrapur. The next one, Rawat, Rajasthan. Okay, then coming to space, we have Artemis Accords. What are Artemis Accords? Firstly, you have to understand the difference between Artemis mission and Artemis Accords. What is Artemis mission? Artemis mission is a planned mission of NASA to send back people to moon again. Okay. So firstly, when did NASA send before? I mean, what was the name of the mission when NASA sent people before? Apollo. Okay. Apollo mission mein NASA has already sent people to moon. Now, like ISRO was formed in 1969. By that time, NASA sent people to moon twice and they came back also. Okay. So Artemis, the mission Artemis is to send humans back to space again. And not just humans, now they are saying ki they'll send a man of color and a woman to moon also. So India becomes the 27th member to sign it, Artemis Accords. So Artemis mission is to send it to moon, but Artemis Accords is like a copy of Outer Space Treaty with some changes. What is this Outer Space Treaty? Or what is this Artemis Accords? Artemis Accords are few governing, what do you call it's like few governing rules which have to be followed by country while exploring space. For example, a country cannot claim that a part of a moon is theirs, a part of asteroid is theirs. So, and peaceful use of space. So whatever related to space, extraterrestrial objects, planets, asteroids, comets, whatever, Artemis Accords covers them, and it basically guides how countries should responsibly work towards space exploration and space technologies. Okay. For example, it urges countries to have interoperable satellites. For example, a satellite is sent by one country. Now, if another country wants to operate it, and if this country wants to transfer it, it should be interoperable, something like that. Okay. It should, for example, the space docking, it should have same dimensions. Our satellite should go dock to International Space Station also. Okay. That is interoperability. So, but you have to understand Artemis Accords are non-binding. Okay. They govern civil exploration and use of outer space, comets, asteroids, moon for peaceful purposes only. Okay, again for peaceful purposes. Now, who are the founding members? UAE is a founding member, Luxembourg, Italy, Australia, US, UK, Canada. Okay, so Artemis Accords is an accord for space, especially for civilian usage of space, peaceful usage of space. But Artemis mission is when we send humans back to moon again. Okay. Coming to Chandrayaan 3. Chandrayaan 3 is country's first, it is the first country, India becomes the first country to successfully land on South Pole. I told you before that, although we are not the first country to land on the moon, but we are the first country to land on South Pole of the moon. Okay. South Pole of the moon often comes, often is on the dark side of the moon. Now, why do we call moon to be on dark side? Why does moon have a dark side? Moon, something like this. So this is Earth, this is moon. People on Earth can always see moon from one side. They cannot see this side. Why? This side is always in dark because moon is tidally locked with Earth. Moon is tidally locked with Earth. Okay. And a lunar day is 14 days. Okay. The length of a lunar day is 14 days. Now, there are some regions on South Pole of the moon which, due to craters, were permanently under shadows. So sun rays cannot reach those regions. And we are expecting there's a lot of water in those regions, frozen parts. So we are expecting we'll find some critical minerals on moon. So that's why we have sent, Chandrayaan 3 to South Pole of the moon. Before us, there was a mission called Luna by Russia. This wanted to land, but this crash landed. Okay, this crash landed. That's why we become the first country to land on South Pole of the moon. Okay, and we become the fourth ever country to actually land on the moon. No country, only 4 countries have landed on the moon so far. Now, Russia, USA, China, and now India. Okay. So Chandrayaan 3 is a frugal mission. When I say frugal, I mean it's a lot. I mean it has been thought that in Chandrayaan 2, which failed,
is
I mean,
being
inside Vikram,
recorded.
there is Pragyan rover. On Vikram, what are the payloads? Payloads first is chased Ramba and seismometer type instruments. So, first just know that Chandrayaan 2 measures moonquakes. Okay, it measures moonquakes. Seismometer type instrument is there, and then Ramba is basically for understanding the plasma density. Chased is to understand thermal properties. You don't have to know the names. Just know that these are. I mean, just have an idea that if you see Chased or Ramba somewhere, these are payloads on lander. On rover, which is supposed to go around, so there is spectroscope. Spectroscope using laser. Now, what is spectroscopy? Spectroscopy is basically a science which tries to guess the material without touching it. Okay. So spectroscopy, whenever you send a laser, there is this laser spectroscope. So without touching that material physically, we are trying to understand what material is moon made of. So that is there in your rover. And there is alpha particle X-ray spectrometer. Again, another different spectrometer. Okay. Now, why Chandrayaan 3 landed during lunar dawn? That means the early in the lunar day. For example, 14 days. Lunar day lasts for 14 days. We landed on first day itself. Okay. The lander and rover has a life of one lunar day. That is 14 Earth days. Because the rover and lander cannot survive the extreme drop in temperatures during lunar night. Okay. But NASA, by sending LUPEX, it did not send it yet. It's planning to send a rover and a lander which can stay intact for 100 days, and its batteries will power it, not solar panels. In general, our lander, our rover are powered by solar panels. Okay, it is not going to be the case anymore when we compare to LUPEX. LUPEX is a future mission of NASA. But it is we wanted to have maximum time, and that's why we choose lunar dawn. That is the morning, the first day of lunar 14 days. Then lander was landed at lunar dawn, so it has maximum time to carry out mission. Now, why to explore South Pole? Due to rugged environment, the polar regions of moon have remained unexplored till date. So the polar regions of moon were not explored. There are indications of presence of ice molecules in substantial amounts in deep craters in this region, indicated presence of water on lunar surface. Due to extreme cold temperatures, anything trapped in this region would remain frozen in time without undergoing much change. That means whatever the craters are there, the water or whatever it is there, it was frozen for a long period of time and it was not disturbed. And we want to study that. Then only we'll understand what was the composition during Big Bang time, or not just Big Bang, or early in the time in universe. Okay, these trapped things provide us clue about early solar system. Now we just have to know, why hasn't any spacecraft ever landed on south pole of the moon before Chandrayaan 3? All landings on moon so far have happened in the equatorial region. Just have to know, all landings, most of them happened in equatorial region. China's Chang'e 4, which became the first spacecraft to land on far side of the moon, does not face the earth. Obviously, right? Far side of the moon is not earth facing side. Landed near 45 degrees latitude, but no one landed at the pole. We landed at the pole. So here, now what next? What next after Chandrayaan 3? ISRO and JAXA are planning LUPEX. Oh, sorry, I by mistake I told ki NASA is planning LUPEX. No, NASA is planning Viper. NASA is planning Viper. LUPEX is what we are planning. LUPEX is ISRO and Japanese Space Agency is planning LUPEX, that is Lunar Polar Exploration Mission, and it is so LUPEX is planning to use ISRO's landing technology only. Okay, so Japan is collaborating with ISRO now. For the first time, some other country is collaborating in our project. Okay, that to a country like Japan. Now, Viper by NASA is planning to stay 100 days on far side or near south pole of moon. Okay. Now, the crash site of Chandrayaan-2 is called Tiranga. Okay, the crash site of Chandrayaan-2 is called Tiranga, and the landing site of this current Chandrayaan-3, the successful landing site, is called Shiv Shakti. Okay, Shiv Shakti, and this happened on August 23rd. Our Prime Minister has declared this to be a National Space Day. Okay, Shiv Shakti, National Space Day. Now, the important discoveries. What happened on due to Chandrayaan-3? We found out that there was sulfur on south pole of the moon. Okay, we found out there was sulfur on the south pole of the moon, and lunar surface insulates the moon. For example, on surface you'll see there's a lot of high temperature, but just beneath the surface there is 10 degrees, minus 10 degrees temperature. This means that there might be a lot of frozen water inside the surface of the moon, and this insulation was noticed by Chandrayaan-3. What did we know? What did it notice? In the surface insulating the inner part of the moon, and sulfur on south pole of the moon. Okay, and sulfur on south pole of the moon. So again, as Artemis Accords are there, I told you there is something called as Outer Space Treaty. Now, what is outer space? Outer space is defined to be the space after 100 kilometers Kármán line. Few people say 80 kilometers is the Kármán line. Few people say 100 kilometers is the Kármán line. Irrespective of what, space is something which, space is altitudes beyond Kármán line. Okay, beyond Kármán line. Kármán line is roughly around 80 to 100 kilometers. Now, so Outer Space Treaty was adopted by UNGA. Not any other country, but Artemis Accords are pushed by USA. Okay. Now, liability. This Outer Space Treaty 1967 has a lot of liability. Liability in the sense that if a state, does something, and it does damage another space object, or if a private company damages the space of some other object, then there is liability clause also. So Outer Space Treaty has liability clause also, and Outer Space Treaty is legally binding. Okay. Now, there's a possibility of Kessler syndrome. What is Kessler syndrome? Kessler syndrome is, this is a previous year question by UPSC also. This is not a disease. This is basically a phenomena where, let's say, one particular satellite got destroyed. Now, the parts of this satellite, the debris, will go attack the other part of other satellites, and that will also blast. Now, it will slowly lead to all the satellites in that particular orbit getting into pieces and creating a lot of space junk. Our communications might be disrupted, our remote sensing might be gone. So these things can happen, and this is called Kessler syndrome. The biggest problem with space debris is the fear of Kessler syndrome. Okay, the fear of Kessler syndrome. Now, what are the issues with space debris? See, what happens is if there's a lot of space debris, then you have to first track where this debris is coming. Even ISRO using Project Netra tracks 10 centimeters objects also. In that big space, just small objects also will track. Why? Because they are moving at high speeds. If they touch a satellite, it will be damaged. So what you should understand is that first we have to track this, and even after tracking, if it is coming in, let's say this is a satellite, if the space debris is coming like this, then this satellite first has to move up, then it has to come back again. So this moving up and down, side, etc., these things will shorten the lifespan of a lot of satellites. Okay, that is something you should know. Then SpaceX. Yeah, this time SpaceX is completely in the news. Just give me a second. SpaceX is also called Space Docking Exercise. It was done at roughly 475-kilometer orbit. Okay, this is very important. SpaceX is in the news, so we'll go a little slow here. SpaceX happened at 475-kilometer orbit. Okay, Now you should know that roughly around 300 to 400 kilometers, you'll find International Space Station. Okay, 300 to 400, mostly at 400 you'll find. So SpaceX was done a little above it first. Next, space docking exercise was done after launching PSLV C60. Now, regarding PSLV, what are the important details? It has 4 stages: solid, liquid, solid, liquid. Okay. Now, the final stage of PSLV was often getting wasted. Okay. So what they did was, very recently, last year only, they had designed a module called POEM. That is PSLV Orbital Experimental Module, which under the final stage of PSLV enables scientists to perform some kind of experiment in it. That means basically it's a space. It's some khali space is there. Why do you want to waste it? Let's do some microgravity experiments. So recently, ISRO has sent some seeds onto the space, and these things grew. How did they grow? They again, they've used some soil and a lot of conditions. There are a lot of challenges of growing seeds in this space. The roots just don't grow properly, and the light also has to be there. In space there won't be any light, so they've designed a small, what do you call, chamber for these seeds to grow. They've taped the seeds, taped in the sense they've made sure that it is covered with soil properly, and the lighting also from what do you call, they had simulated day and night. For example, it used to burn for 12 hours, light used to be there for 12 hours, and turn it off for 12 hours. So this happened in something called as POEM4, that is PS4 Orbital Experimental Module. That is PSLV Stage 4 Orbital Experimental Module. Okay, this CROPS, that is Compact Research Module for Orbital Plant Studies. This is the CROPS module was sent by ISRO, not by any private company. Compact Research Module for Orbital Plant Studies. This you have to know. Now, this is PSLV C60. You have to know that also. Why? Because SpaceX was done on payload sent by PSLV C60. Docking. First, when was the first docking happened? So first docking happened in 1966. ISRO was not even formed. Now we are docking. We are trying to dock, but they've docked way before. So in 1966, it was by Gemini 8 and Neil Armstrong. He was the commander, and it was a docking which was done by people. He was present in the space. He docked it. He navigated it. It was not autonomous docking. Autonomous docking without any person was done by Russia. Okay. Today we also did autonomous docking only. Okay. We didn't send anyone to the space. Now note, Bharatiya Antariksha Station, that is Indian own space station, it is envisaged to be fully operational by 2035. Okay, it is envisaged to be fully operational by 2035, and again they said we'll start launching from 28, and slowly we'll build it. And that is SpaceX is an important mission, because only when you can dock can you make a huge space station. For example, it's like you cannot send all the 6 BHK house at once into the space, right? You have to send small parts and eventually make 1 BHK, 2 BHK, 3 BHK, like that. Okay, just know that Bharatiya Antariksha Station will be ready by 2035. Launching will be started by 2028. Then this is POEM4, but there's something called as POEM3 also, the previous PS4 Orbital Experimental Module. So the stage 4, final stage of PSLV, is used as an area or space to perform some experiments. Generally, 4th stage becomes space debris. Other 3 stages fall into ocean. You should know 4th stage becomes space debris, but we're planning to use it. So it is equipped with, what happens normally? So it is equipped with, okay, what's happening? Okay, so it is equipped with what? Some solar panels, gyroscopes, and batteries. Why gyroscopes? To maintain stability. Batteries is to do some experiment, and solar panels to get power. Okay, so POEM3, this is about POEM3. ISRO has recently announced that POEM3 has re-entered Earth atmosphere without leaving any space debris. The event was part of PSLV C58. So this C58 had a very important mission called EXPOSAT. EXPOSAT. What is EXPOSAT? EXPOSAT I'll see if I had made notes for Exposat. This is Exposat. So Exposat is X-ray polarimeter satellite. This is by ISRO. So before you understand anything else, you have to understand one particular topic, that if a star today emits some kind of rays, let's say gamma rays it's emitting, okay, after some billions of years, it will slowly change into X-rays, slowly change into then UV rays, then visible, micro, IR. So when you are studying X-rays of today from space, then you're actually going back in time and studying when that event happened, millions of years back in time. Okay, that is Exposat for you. So Exposat is now India's second observatory after Astrosat. Okay, Astrosat was India's first space observatory, which viewed the space in visible, UV, and X-ray. All three. X-ray, no? Visible, UV, and IR. I think visible, UV, and IR. But just know that Astrosat had multiple. Okay, it has visible, it has UV also. But Exposat is completely only on X-ray. Okay, it's completely for X-ray. It is placed in low Earth orbit, 650 kilometers. Okay, it was sent by PSLV C58. It was sent by PSLV C58. Then the instruments. What are the instruments on this Exposat? Exposat full form is X-ray polarimeter satellite. Okay. Now, X-ray polarimeter. That is, it had two instruments. That is X-ray spectrometer, a spectrograph, or sorry, spectroscopy. X-ray spectroscope, and Polix. Polix is X-ray polarimeter. What does this polarimeter measure? It measures medium energy band for the first time. Even NASA did not send until today medium energy band measuring instrument into the space. Okay, so we are sending it for the first time. Now NASA also has soft X-ray, that is low band, not medium X-ray band. Spectroscopy. So it is nothing but giving details about material without touching it. Right. It is based on C.V. Raman's principle. Raman effect. What is Raman effect? Change in wavelength of light once it is put onto a surface. So once light touches surface, there will be a slight change in wavelength. That is Raman effect. And see the small information here. Tiangong is Chinese space station. Tiangong is Chinese space station. Yeah, Tiangong is Chinese space station. Then we finished dogleg manure, right? Dogleg manure yesterday. Yeah. Astrosat, yes. Yes. So Astrosat is India's first indigenously built dedicated space telescope or space observatory. It simultaneously views in visible, that is optical, UV, and X-ray together. Exposat is completely X-ray. Okay. That's also like a telescope only. These are Astrosat and Exposat, both are space telescopes. Now, here, no IR. IR is only in James Webb Telescope. Okay, James Webb Telescope. Now, INSAT. I told you that INSAT satellites are always, INSAT satellites are communication satellites, right? Except 3 series. INSAT satellites are communication satellites except 3 series. That 3 series is 3D and 3DR. So whenever you see INSAT somewhere, INSAT 3D, INSAT 3DR, that means you're looking at Earth observation satellites. Okay, you're looking at Earth observation satellites, INSAT 3D and INSAT 3DR. Now, what is INSAT 3DS? INSAT 3DS comprises of 4 payloads: an imager, a sounder, S is for sounder, a data relay, D, data relay transponder, and a satellite aided search and rescue transponder. See, I think now you see this multispectral imager will generate. So what is INSAT 3 series? These are Earth observing satellites. INSAT 3 series are Earth observing satellites. First point. Second point, INSAT 3DS has imager and a sounder also. Okay, that is something you should know. Okay, there's some problem with this. I'll better not go towards the board. So this Earth observing satellite has multispectral imager. That means it will see Earth in 6 different wavelength bands. It can see in 6 different wavelength bands, and the sounder will generally contribute in creating vertical profiles of atmosphere. That is temperature, humidity. Okay, so sounder is used for vertical profiles, imager is used for horizontal profiles, and imager is multispectral imager. Okay. ఓ బోర్డ్ అన్లోడ్ చేయొచ్చా వాళ్ళు? అన్లోడ్ చేసే ఛాన్స్ ఇక్కడ లేదు కదా, నాకు తెలిసి బోర్డ్ కాదా? ఓకే ఓకే అవునా? ఓ ఓకే, హౌ షుడ్ వి స్టాప్ దిస్? అవునా? ఓకే, whoever is doing this, you know, don't try to zoom your tab or anything else like that. Okay, now ఈ స్క్రీన్ షేర్ వాళ్ళకి ఇదే అవుతుంది షేర్, మీకే ప్రాబ్లం అవుతుంది అనుకుంటా, వాళ్ళకేం అవ్వదు, రైట్? యా, వాళ్ళకి కరెక్ట్గానే చూపిస్తుంది. సో if someone's watching online and someone's zooming, do not do that. పక్క అక్కడే చేస్తున్నారా? ఇషారా? ఓకే, someone like ఇట్స్ ఓకే నా. నాకు తెలిసి బోర్డుదే ప్రాబ్లం, ఇంకా వాళ్ళు ఏం చేయరు, బోర్డు కదా ఇది. యా, సో now we'll come back and look at POEM3 is done. So this is your POEM3. ISRO has recently announced that this C58, that is Exposat mission, it is aimed at reducing space debris by leaving virtually no debris in orbit. Okay, the PSLV C58 mission successfully concluded on Jan 2024. So this is Jan 1st 2024 current affairs, but it's an important aspect. So this is POEM3, that is the 4th stage of PSLV, which was previously not used. So basically PSLV has how many stages? 4 stages: solid, liquid, solid, liquid. The 4th stage used to be ended up as the space debris. Okay, it was not used, but ISRO has now started using the 4th stage of PSLV because there was enough space left. Okay, and it is doing some experiments. For example, they grow crops. We just saw they grew crops inside this. So PSLV has 4 stages, and first 3 stages fall into the ocean. The 4th stage, known as PS4, usually becomes space debris. However, in C53 mission, from C53 mission, PS4 is a stable platform now, and experiments are performed in it. In C58 mission lo POEM3, C60 mission lo POEM4, C60 lone crops vachinayi, ante they grew some plants in space. Yeah. Then you have POEM has its own POEM has its own navigation guidance system. The system acts as platform's brain, ensuring it to stay in a stable position accurately. So it has a lot of gyroscopes also. So this final stage of PSLV stays stable. Now for navigation, it uses 4 sun sensors, etc. See, what is the difference between POEM and satellites? Satellites are specialized spaceships built for long-term missions, such as weather monitoring, communication, etc. They have their own power, communication systems, and they can stay in orbit for years. POEM is very different. It is only in orbit for temporary time. I mean, it is a temporary orbital lab created by repurposing rocket's final stage, right? Instead, so it carries scientific experiments into space for a short period using basic controls for stability. It uses only basic controls. Now, instead of staying in orbit for a long time, POEM is designed to safely re-enter Earth's atmosphere. Okay. Now, yeah, the recent ESA's Proba 3 mission. So what is this Proba 3 mission? So, see, you see, ESA's Proba 3 mission works on a principle of solar eclipse and it wants to study sun. For example, what happens during solar eclipse? This is Earth, this is Moon, this is Sun, no? Sun is big, right? Now, Earth, Moon, Sun. But during solar eclipse, if it happens, a particular area will go dark. For example, if you move your hand towards your eyes, you'll be blind. But if you move your hand far, you can see a lot of world, right? So Proba 3 now tries to study sun. But if you want to study sun and it wants to study sun's outermost layers, the sun has majorly 3 layers. Next page ఎట్లా వెళ్తారు ఇదా ఓకే ఇది అనొచ్చా పైకి ఇది రావట్లేదు బట్ ఇదా ఓ ఓకే గాట్ సో సన్ లో 3 లేయర్స్ ఉంటాయి ఓకే సన్ లో 3 లేయర్స్ ఉంటాయి ది outermost layer I mean this is not layer anam దీన్ని it's like atmosphere of sun ni corona antaru okay atmosphere of sun is called corona. What are the other layers? Let's say if we have to cut sun like this, వేరే బయట లేయర్స్ ఏవో ఉంటాయి we don't need them, we need only 3 layers. Oh sorry, this is also we don't need. We have photosphere here, photosphere, then we have chromosphere, then we have corona. Photosphere, chromosphere, corona. I think the major point which you have to know is that this corona has more temperature than photosphere. You think sun low deeper layer should be having more temperature, right? But no, this corona has higher temperature than photosphere. And if you study corona properly, there are 2 phenomena. One is solar flares. Solar flares are nothing but charged particles coming out of corona. Charged particles. Now, charged particles are often in form of plasma. Plasma ante enti fourth state of matter. That charged particles come out of this corona, and these are solar flares. These affect Earth's atmosphere. These come to Earth and they interact with our own magnetic field, Earth's magnetic field, and the charged particles here form auroras here. Sometimes if the solar flares are heavy, they can disrupt the satellite communications. They can damage the satellites. Okay, Elon Musk, the Starlink satellites have been damaged due to some solar flares. Okay, so these are powerful particles. Now, what stops these solar particles? In general, Earth's magnetic field stops. So, what is this belt around Earth which is saving us using magnetic field? Which belt is that? It's called Von Allen belt. It's called Von Allen belt. Okay, VONALLEN. Von Allen belt is a belt wherein the magnetic field of Earth tries to, magnetic field of Earth acts as a shield around Earth. Okay, that is Von Allen belt. Now, this is solar flares. Solar flares are small, okay, but sometimes there can be something called as CMEs, coronal mass ejections. That means huge blasts from corona, mass coronal ejections. Okay, so coronal mass ejections, you have to understand that these are solar flares are some particles coming out. This is like bombs coming out of sun, solar bombs coming out of sun. Okay, so these can also cause huge disruptions, right? That is something you should know. Even satellites can be damaged, and these, if you study corona properly, you'll be able to understand these 2 phenomena better. That's why we sent Aditya L1, okay, to study sun. And we are also trying to send, NASA has previously sent Parker solar probe, etc. The point is, Now, if you have to study sun's outer atmosphere, you cannot first of all see it. How will you study? Why? Because sun is so sharp and bright that outer layer is hardly seen. But when you look carefully during eclipse, what happens is sun is covered by moon, so you can only see. So you will see something like this, some bright outer disk of sun, right? That is corona of sun. Corona of sun is seen by us. Okay, some brighter layer. Okay, so this corona of sun, you can only properly study it during eclipses, but you cannot. But I mean, eclipses are not happening every single day, right? If you have to study it constantly, what will you do? You create an artificial eclipse. You have a camera, and you make sure that you put your hand like this in front of camera. So what happens? If this is sun, I mean, if this is sun's view, now you're blocking all of this sun's view with another screen. Then faint glow అంటే చిన్నగా ఇట్లా గ్లో అవుతుంది కరోనా, like solar eclipse only. So Proba 3 mission, I repeat, Proba 3 mission by European Space Agency is trying to do almost the same thing. It is placing, if this is a satellite, it is placing another satellite connected to this just to cover sun. So ఒక బాల్ ముందు పెడుతుంది, కెమెరా ముందు ఒక బాల్ పెడుతుంది లిటరలీ సన్ ని కవర్ చేయడానికి. దట్ ఈస్ ప్రోబా 3 మిషన్ ఆఫ్ యూరోపియన్ స్పేస్ ఏజెన్సీ. ఓకే, ప్రోబా 3 మిషన్ ఆఫ్ యూరోపియన్ స్పేస్ ఏజెన్సీ. See, ISRO launched. Now, why is it important for us? European Space Agency mission, they've launched it from our own Sriharikota. ISRO launch చేసింది మన కోసం, వాళ్ళ కోసం ISRO launch చేసింది. Previously we used to go with our satellites. Now they are coming to us. Okay, so ISRO launched it in PSL LV XL, and it is in elliptical orbit. It is not in solar normal orbit. It is in elliptical orbit. Okay, earth చుట్టుపక్కల అది elliptical orbit లో తిరుగుతుంది. Then it has two spacecraft attached to each other. చెప్పిన ఒక కెమెరా ముందు బాల్ పెట్టినట్టు. One is coronagraph, that means camera. Coronagraph అంటే it will study corona. The other one is occulter. Occulter, it's like it will cast shadow on corona, sorry, on coronagraph spacecraft. So the smaller one will cast shadow on this bigger one. This is coronagraph, this is occulter. Occulter అంటే ఈ బాల్, కెమెరా ముందు ఒక బాల్ డిస్క్ పెట్టినట్టు. Okay, then in orbit demonstration. So once it is in orbit, it will study corona in visible UV and polarized light. Okay, simple. ESS Proba 3 ni manam launch chesinam. It is studying corona. How is it studying? By creating artificial solar eclipse. Okay, it has, so flying in tight formation about 150 meters apart. So how do you create artificial solar eclipse? You fly very close to each other. Listen here. How do you create artificial solar eclipse? You fly very close to each other. This ball and this camera is right here. These are flying very close to each other. Okay, like that. Then INS Arighat. Okay, this is a nuclear capable submarine, nuclear power submarine, which has been launched, or which has been launched this year only. So it is a nuclear capable submarine. It can launch K4 Sagarika. K4 Sagarika is a sea launched ballistic missile. From sea you can launch. It is nuclear capable and it has 3,500 kilometer range. Okay, it has 3,500 kilometer range, and this Arihant class specifications, you don't need all of this. But INS Arighat is Indian Navy's second indigenously designed and built Arihant class submarine. First the INS Arihant, that is aircraft carrier. Vikrant is aircraft carrier. Okay, Vikramaditya is aircraft carrier. అంటే పెద్ద షిప్స్ అవి. ఇవి సబ్మరీన్స్, వాటర్ కిందికి పోతాయి. ఓకే, ఫస్ట్ ఇస్ అరిహంట్, సెకండ్ ఇస్ Arighat. Okay, both are indigenously designed and made. Both are indigenously designed and made. Okay. Then you have Yeah. You see, India's submarine fleet, a fleet mein, there is nuclear powered ballistic missile submarines. There are only two nuclear powered ballistic missile submarines. And there is nuclear attack submarine, I'll tell you. So, the nuclear power, nuclear power, whenever I say SSBNs, those are nuclear powered ballistic submarines. That means they are powered by nuclear energy only, but they can fire ballistic missiles which are nuclear capable. అంటే సీ లోపల నుంచి మిసైల్స్ లాంచ్ చేయొచ్చు. ఐఎన్ఎస్ చక్ర కెన్ ఓన్లీ అటాక్ న్యూక్లియర్ అటాక్ సబ్మరీన్ అది. ఓకే, ఇట్ ఇస్ నాట్ న్యూక్లియర్ పవర్డ్, it is nuclear attack. That means it is powered by some other things, diesel maybe, but it has nuclear weapons in it for it to launch. Then diesel electric submarines, 14 of them, those are Scorpion class. Okay, diesel electric submarines are Scorpion class. Kalvari class, you have two small submarines. Then you have Kishimar class, you have small submarines. But I told you diesel electric submarines Scorpion class mostly. Okay. Then we have, yeah, before we going to something else, we'll look at the all operations first. What is Operation Ganga? Operation Ganga, from Ukraine we got our students. Operation Ganga. Okay, Operation Ganga, Ukraine, they might ask you. Then Operation Kaveri, from Sudan. From Sudan we got people, Hakipiki tribes, etc. Then Operation Ajay. Operation Ajay, I forgot this. Israel, yeah. Operation Hamas-Israel conflict. Yes. Hamas-Israel conflict is Operation Ajay. What is Operation Cactus Sunrise? They won't ask you. Yeah, Operation Dost is this. Syria and Turkey earthquake. Syria and Turkey earthquake. We gave some relief, no? Earthquake relief. Charity. Okay. Operation Dost. All this you have to remember. And there's another thing, no? Operation Devi Shakti. Operation Devi Shakti is Afghanistan. Yes. Operation Devi Shakti is Afghanistan. We got our people from Afghanistan. All these operations. Operation Vande Bharat COVID time. Operation Vande Bharat COVID time. Now all the exercises, I'll draw country here. So let's just imagine this is India. Now IMBEX here, India Myanmar bilateral exercise. Sri Lanka Tony Mitra Shakti, perfect. With Bangladesh Sampriti. Sampriti. Next with Pakistan Nepal Surya Kiran. Maldives Ikuverin. EKUVERIN. Ikuverin. China hand in hand. Indonesia Garuda. Operation Garuda with Indonesia. Then with USA Vajra Prahar, Tiger Triumph. Okay, Vajra Prahar, major ones. We do a lot. Vajra Prahar, Tiger Triumph. Vajra Prahar wrong, yeah. Tiger Triumph, Then, yes. Pardon? Indra. Russia's IND, Indra. Now we look at defense aspects. Wait. So what is Operation Sankalp? Operation Sankalp is this is also pretty much in news. So Operation Sankalp is to secure shipping lanes, from Red Sea to Strait of Hormuz. Red Sea to Strait of Hormuz. Okay, so we'll draw it, but just know that Operation Sankalp, Red Sea to Strait of Hormuz. Akada, there is a lot of piracy in Horn of Africa region. There's a lot of piracy happening. I'm sure you must know it. Okay, I'll draw it here only. Show it to you. So let's say okay, this is Red Sea. I mean, this is a bad diagram. This is Red Sea. This is Bab el Mandeb. Then this is Gulf. This is Gulf. So this Operation Sankalp is to secure what is Strait of Hormuz? Strait of Hormuz. Oops. So it is between which two countries? Strait of Hormuz? Iran and Iran. Okay, I'll have to wait. Strait of Hormuz, I'll show it in the map only. Else you'll be confused. This is Strait of Hormuz. See this. This is Strait of Hormuz. Persian Gulf, Iran, Oman. This is Oman. Okay. UAE. Strait of Hormuz is between Iran and Oman. Okay. UAE, very little. This is Saudi Arabia. Persian Gulf. This is Strait of Hormuz. A better image will be if you look at this Strait of Hormuz. Okay, Oman. So whenever you say Strait of Hormuz, Oman inka Iran. It is between Oman and Iran. Okay. So this is Red Sea. So this area is susceptible to piracy. Why? Because Somalian pirates are famous there. Horn of Africa region. Seed countries. Yeah. So this region is susceptible to piracy. Right. Here Indian Navy came and it did something called as Operation Sankalp. Okay. Did Operation Sankalp. Now, then you have two nuclear powered submarines, INS Arihant and INS Arighat. Okay, INS Arihant is a nuclear powered submarine. INS Arighat is the second Arihant class submarine. Okay, it can carry 12 K-15 SLBMs. Okay, then it is a ship submersible ballistic nuclear submarine. Ship submersible ballistic nuclear submarine. It's not that important. Just know that it can launch ballistic missiles. Now, Project 77. There is something I told Project 75. What is Project 75? It is for Scorpion class submarines. Mazagon Dock Limited. Scorpion class submarines are untai. Perlu enti? Okay, I'll not go there. I'll write here only. Yes, 3 V's, 3 K's. What are 3 K's? Karanj, Kalavari, Kaveri, I think. Then 3 V's is Vela, Vagir, Vakshir. Vela, Vagir, Vakshir, Karanj, Kalavari, Kaveri. Okay. These are Scorpion class submarines. Okay. Diesel electric submarines. With whose help we are doing it? France. France is helping us to do. And this is different. Now, Project 77 is this will take a lot of time, but approval came for ship submersible nuclear submarines. So we are now planning to make more nuclear submarines. Okay, we are now planning to make more nuclear submarines. We did what is gravitational lensing before. We also covered dogleg maneuver, right? Yeah, we'll cover Bharati Antariksh Station. When are we planning to launch this? 28 lo will start. When will it end? Complete 2035 lo will complete building Bharatiya Antariksh Station. Okay, it's a planned station between 400 to 450 kilometers above the Earth's surface, which has 5 modules and will be constructed in phases. Any modules? 5 modules. Okay, 5 BHK. We're having 5 BHK in space. Now, the first model, known as the base model, is scheduled in 28. It is expected to be fully operational by 2035. Okay, 2035. The Bharati Antarctic Station is currently in conceptualization phase. Okay, we're just having a design, bedam, etc. Thinking. Then there is something called a small satellite launch vehicle. Okay, the small satellite launch vehicle is so important that for it only we are making, what do you call, a launch station at Kulashekarapatnam, right? Yesterday we saw dogleg maneuver, Kulashekarapatnam. The small satellite launch vehicle gurinchi few things you have to know. To make a PSLV, it will take you roughly 45 days. Lot of money also. To make an SSLV, it will only take you 72 hours. That's it. So ISRO again, PSLV any stages? 4 stages. Solid liquid, solid liquid. SSLV 3-staged launch vehicle. Okay, and final stage ni stage anaru. So SSLV everana any stages anadu 3 stages cheppali. Final has liquid terminal, I mean velocity terminal something edo untadi. Wait, velocity trimming module అని ఉంటుంది. Okay, pardon? Yeah, liquid propulsion terminal stage. Terminal అంటే final, liquid propulsion అంటే it uses liquid అని అర్థం అంతే. లిక్విడ్ ప్రొపల్షన్ అంటే ముందుకెళ్ళడం, లిక్విడ్ తో ముందుకెళ్ళడం. టర్మినల్ అంటే లాస్ట్. అందుకే చెప్పిన 4 స్టేజ్లు కాదు. లేదు 3 స్టేజెస్. ఫోర్త్ స్టేజ్ కాదు అయితే ఇట్స్ కాల్డ్ వెలాసిటీ ట్రిమ్మింగ్ మాడ్యూల్. వెలాసిటీని ట్రిమ్ చేస్తుంది అది. లాస్ట్ మాడ్యూల్ కొంచెం ట్రిమ్ చేసి పెడుతుంది. జస్ట్ నో దట్ SSLV ఎన్ని స్టేజ్ అని అడిగితే 3. ఓకేనా, ఎందుకంటే వాళ్ళు అట్లనే రాశారు ఎవ్రీ సింగిల్ దగ్గర. నేను ఒకసారి 4 అనుకుని ఒక టెస్ట్ సిరీస్ లో 4 పెట్టిన, రాంగ్ ఆన్సర్ వచ్చింది. సో it is 3 stage only. Okay, and a liquid propulsion terminal model, and it is specifically designed to launch small satellites 10 to 500 kg to low earth orbits. Okay, 10 to 500 kg to low earth orbits. When we do what do you call space, I'll tell you in detail, but for now it's done. These satellites are often referred to as mini, micro, nano satellites. It's for smaller satellites to low earth orbits, not medium or geosynchronous. No, SSLV, that is small satellite launch vehicle missions, are cost effective and they enable quicker satellite insertion into orbit. Quick, right? In 72 days it will be done, right? The first mission of SSLV, in fact oka laptop to launch cheyochu, just oka laptop, 72 hours, that's it. That is SSLV. Now the first mission to SSLV, was it launched? Yes, it was launched. What did we launch? Earth observation satellite 2 and Azadi Sat, but it was unsuccessful. Why? Deviation. And what happened, this launched properly but it couldn't insert properly. Then the second mission in February was successful. It inserted 3 satellites. Okay, so launch aina gani konnisal insertion avvadu. Okay, that you should understand. పడిపోతాయి అక్కడ ఆగు ఇంకా. Now there is something called as reusable launch vehicle called Pushpak. Okay, ISRO the reusable launch vehicle parenti Pushpak. This Pushpak, ISRO has successfully carried out its landing mission of Pushpak reusable launch vehicle landing experiment from aeronautical test range at Challakere near what do you call Karnataka, Chitradurga. So Pushpak testing ekkada ayindi, Karnataka lo ayindi. Okay, that's it. Then RLV, that is reusable launch vehicle landing experiment, LEX ante landing experiment, is the second series of experiments conducted by space agency. Ante important kaadu. Pushpak ante enti reusable launch vehicle. Any launch vehicles unnai ippudu currently operational? PSLV, GSLV, SSLV, PSLV, GSLV. Now we are wanting another reusable launch vehicle, but it's still long way to go. Okay, reusable launch vehicle కావాలనుకుంటున్నాం, and this demonstrated the autonomous landing capability. సో ఎక్స్పెరిమెంట్స్ ఏం చేశారంటే వచ్చి ల్యాండ్ అయితే అవుతుంది కరెక్ట్ గా, కానీ మెటీరియల్ ఇంకా ఇవన్నీ ఫైనలైజ్ చేయలేదు. ద వింగ్డ్ బాడీ అండ్ ఆల్ ఫ్లైట్ సిస్టమ్స్ యూజ్డ్ ఇన్ RLV LEX-1 వర్ రీయూజ్డ్. చూడు, ఫస్ట్ ఎక్స్పెరిమెంట్ ఏదో అయింది కదా, ఆ తర్వాత దాన్నే రీయూజ్ చేసి సెకండ్ పెట్టారు. ఎందుకు? వాట్ ఆర్ వి డూయింగ్? రీయూజబుల్ లాంచ్ వెహికల్ ఎక్స్పెరిమెంట్ చేస్తున్నాం కదా. So a lot of components were reused. Just no example ఏమొస్తుంది అంటే పుష్పక్ అంటే ఏంటి మళ్ళీ యూజ్ చేయగలిగిన లాంచ్ వెహికల్ రీయూజబుల్ లాంచ్ వెహికల్ ఓకే పుష్పక్ ఇస్ అ స్వదేశీ స్పేస్ షటిల్ is India's futuristic reusable launch vehicle. Okay, the rocket names comes from Pushpaka Vimanam in Ramayana. Then ఏంటి పేరా అంతే కదా ఆల్మోస్ట్ అదే చేస్తారు వీళ్ళు సో రీయూజబుల్ లాంచ్ చేస్తే ఏమవుతుంది మినిమైజెస్ ద స్పేస్ డెబ్రీ కదా యా యా మోస్ట్ ఎక్స్పెన్సివ్ పార్ట్ is the upper stage. Okay. It is designed as an all rocket fully reusable single stage to orbit vehicle. Okay, single stage. Okay, stage to orbit vehicle. Then we have a lot of moons, etc. Yeah, first let's do Pralay missile. Pralay missile is in the news. It is short range surface to surface missile, which is quasi ballistic. What do I mean by quasi ballistic? When you launch a ballistic missile like this, then if you can start changing slightly, not so much, ఇప్పుడు ఇక్కడ నుంచి ఇట్లా తిప్పి ఇక్కడికి రాలేవు. If you can slightly change, not drastically change, like this or like this is called quasi ballistic. Pralay is India's quasi ballistic mission. Okay, missile. It is surface to surface only. Okay, then it does, what do you call, it achieves hypersonic speeds during descent. You should know that it can achieve hypersonic speeds during descent. Ante eppudaina I told you last class also, these ballistic missiles can also achieve hypersonic speeds, but only during descent. Okay, then it is definitely nuclear capable. Then mission Divyastra was discussed, right? MIRV. Then Israel's anti-missile defense system. So firstly, you should understand Israel has not just Iron Dome. Israel has three kinds of missile defense systems. First is Iron Dome, which is for short range rockets. Okay, it is unguided rockets typically fired from Hezbollah and Hamas. Then mid range is something David Sling. Long range Arrow 2, Arrow 3. Mid range David Sling. David Sling was used when Iran launched rockets on Israel. Okay. Then Arrow 2 and Arrow 3 are these systems handle even longer range ballistic missiles, including intercontinental ballistic missiles. Okay. Then you have, yeah, that's it. Then, yeah, Israel defense experts highlight that these systems give Israel a crucial upper tier protection from threats like Iran. Okay. Now you should understand India and Israel are working on which missile defense system? Barak 8. India and Israel are working on Barak 8. Okay. What are the missiles we get from Israel? Lot of them, but famous are from Spider and Derby. Spider and Derby are famous. Then we have, yeah, BrahMos extended range, 800 to 900 kilometers. BrahMos extended range. Then there is BrahMos 2. K is for Kalam or Abdul Kalam. BrahMos 2, K is for Abdul Kalam. It is a hypersonic missile. It is in undermaking. What is BrahMos ante? What do you say? It is supersonic cruise missile. BrahMos is supersonic cruise missile. Okay, but BrahMos 2K is going to be hypersonic missile. Okay, it's hypersonic missile. Note, Indonesia and Philippines both brought BrahMos. I told you Philippines also brought China torpedo. Okay, okay, torpedo name, indigenous torpedo's name is China. Philippines brought it. Okay, then just know that BrahMos Philippines and Indonesia bought it. Then ITL1, we'll take a small break and we'll come back. Okay, we'll finish this space and we have some miscellaneous topics left. Okay, that we'll try to finish. అది OneNote ఫైల్ అందరికి యాక్సెసిబుల్ ఉండదు, నాకు మళ్ళీ వెబ్ లో మీకు లోడ్ చేసుకోవాల్సి వస్తుంది. రాలేదా? Matlab, yeah, working. So we discussed Pushpak. Pushpak is a reusable launch vehicle, right? Tiangong. Know the name of Chinese space station? It is Tiangong. Okay. The name of Chinese space station is Tiangong. Moons. So again, although not really important, but if you have an idea, these are always in the news. For example, Ganymede is Jupiter's largest moon. Okay. Ganymede is Jupiter's largest moon, and Titan is Saturn's largest moon. Okay, who has many moons? Saturn has largest number of moons. Okay, so Titan is the largest moon of Saturn. Ganymede is largest moon of Jupiter, and there are two moons for Mars, Phobos and Deimos. Okay, Phobos and Deimos are it's not there. You can probably write Phobos and Deimos are two moons of Mars. Okay, now Mimas is a moon of Saturn. So what happens is there is a mission called Cassini-Huygens mission. So this investigated Enceladus. Okay, Enceladus is one of the moon of Saturn. Okay, Enceladus. No, just know that Cassini-Huygens mission is related to Saturn. That's it. Cassini mission, then gurinchi Saturn gurinchi. Who sent? NASA. Okay. Again, Pushpak. So Pushpak has scramjet engine. We discussed what is scramjet engine, supersonic combustion ramjet engine. These are also called air breathing engines. They perform well at supersonic speeds, but to take them to supersonic speeds, you need some solid propellant, solid booster in the first phase. Okay. Now, what do you call scramjet engine? So using scramjet engine reduces mass and cost. So what happens is, if you are using reusable launch vehicle, then most of the time you are in atmosphere only, and there's air in atmosphere. But when you are in space, you don't have air in space, so your fuel has to be burnt along with an oxidizer. But if you're in atmosphere, you don't need the oxidizer. Oxygen will directly come from air. So that's why scramjet engine is used in reusable launch vehicles to reduce the need for carrying extra oxygen, because extra oxygen is extra weight, right? So just know that using scramjet engine in Pushpak will will reduce the cost, since there is no oxidizer. Okay, then hydrogen is the fuel. Okay, for Pushpak, hydrogen is the fuel. Then ISRO's reusable launch vehicle is like American space shuttle. That means it will come and it will launch. It will land like this. It will land like a plane. This reusable launch vehicle will land like a plane. Okay, just know that. And we finished POM1. What is Tiangong? China's space station. So China conducted first crewed space mission in 2003. Till now we couldn't send one person to space. Okay, China conducted it in 2003 only. Okay, so when was China's first crewed space mission? 2003, becoming the third country to do so. Okay, and what are the previous space stations? Currently there is International Space Station in Tiangong, but what are the previous space stations? There was Skylab by NASA, and there was Salyut-1 by Russia. Okay, in this Salyut-1 only we sent Rakesh Sharma. Okay, who's famous what do you call speech is there, right? Sare jahan se acha. Indira Gandhi asked him ki how is India looking from above? He's like Sare jahan se acha. But you also have to know few more things, although not important. He did yoga there. He learned yoga and he went, and he's from Hyderabad only. He studied in Nizam College. Okay, so this Rakesh Sharma had 1 week long stay there. He carried soil from Rajghat, Gandhiji's grave, to space. Okay, we discussed this yesterday about neutron stars. This was done yesterday, right? Neutron stars. Then now Aditya L1. So firstly, what are Lagrangian points? Aditya L1. That means, what is L1 in Aditya L1? Lagrangian point 1. Now, what are Lagrangian point 1 points? So if this is Sun, if this is Earth, there are some points such as L1, L2, L3, L4, L5. Okay. Now, at these points, what happens is Sun's gravitational pull and Earth's gravitational pull balance each other out. That means if an object is placed at this L1, L2, L3, L4, L5, it will stay stationary with respect to Sun and Earth. Okay, it will stay stationary like that. These are like parking spaces in space. So how do you define Lagrangian points? The points where the gravitational pull of two planetary bodies or two bodies balance each other out. Okay, those are Lagrangian points. So Aditya L1 is a point which allows our satellite to have a constant look of Sun. Okay. And what objects are at L2? James Webb Telescope is placed at L2. What is James Webb Telescope? A telescope designed by NASA to look into infrared radiation. That means it is like Hubble telescope only, but remember Hubble telescope was in the low Earth orbit. It was revolving around here. James Webb telescope is way far. It's an L2 point. Okay. So L1 point lo Aditya L1 is there. So how did it leave? See, if this is Earth, Aditya L1 just slowly went like this. These are called slingshot maneuvers. It slowly exited the orbit. I mean escape velocity. Then now here it reached L point, and at L1 it will have an halo orbit. That means it will not just go stay at L1. It will rotate like this. So it will have a halo orbit in L1. So just know that Aditya L1. We discussed who is the project director of Aditya L1? Nigar Shahji. Nigar Shahji. Okay. So Aditya L1 may you have halo orbit. Okay. So Aditya L1 mission capabilities and goals. Aditya L1 was launched using PSLV XL, okay, from Satish Dhawan Space Center in Sriharikota to establish a solar observatory at halo orbit around the L1 Lagrangian point of Earth, Sun-Earth system. See, Lagrangian points exist for Moon-Earth system also. Lagrangian points exist for Moon-Earth system also. They exist for Sun-Earth system also. So Lagrangian points exist between any two planets. Okay. Now, major science objectives is understand coronal heating. So Aditya L1 wants to understand how is corona heated. So there is this theory that corona is more hot than photosphere. No, why? So there is a theory of solar spicules. That means there are some spicules which are narrow bands of energy going into corona and heating it up, something like that. Those spicules are not visible karke. So we want to test this theory. Okay, so it will understand coronal heating, how corona is getting heated. It will understand solar wind acceleration. Okay, understanding initiation of coronal mass ejection, solar flares, and near Earth space. Okay, understanding initiation of, see, I told you what is a coronal mass ejection, right? It is burst of charged particles from Earth, from Sun, and then solar flares is a little, what do you call, smaller phenomena. Then understand. So basically, Aditya L1 wants to study coronal mass ejections and solar flares. Now, understanding coupling and dynamics of solar atmosphere. Understanding coupling. So it wants to understand how Sun's atmosphere is working, and it wants to understand solar wind distribution. Okay. Now, what does it have? It has a coronagraph, visible emission coronagraph to observe corona. It has solar UV imaging spectrum. Now, this is very important. Even Proba 3, which we saw, will photograph Sun under UV spectrum, spectrum. Okay. So Sun is always, Sun is often photographed under UV spectrum. Adi gurtupettukondi. So Proba 3 was launched by ISRO. ISRO launched Proba 3. Proba 3 was the European Space Agency's mission, right? It was a European Space Agency's mission. It was launched by ISRO. That's why we are studying it. Now, what is it meant to do? What is Proba 3 meant to do? What is it meant to do? It is meant to study corona only. Okay, Proba 3. I told you, right? Two satellites at 150 meters, just 150 meters away from each other, are moving together to induce a phenomena called artificial solar eclipse to study corona. Okay. And then there is obviously an X-ray spectrometer. See, X-ray spectrometer is almost there in all of the missions. For example, in Pragyan rover, in Chandrayaan 3, there is X-ray spectrometer. Okay. Then Aditya solar wind particle experiment. There's some experiment there. And plasma analyzer. I told you sun is made of plasma. Universe low 90% of what do you call mass is made of plasma. Okay, 90%. Plasma is the fourth state of matter. It comes after you heat gas a lot. Okay. And there are some digital magnetometers to understand sun's magnetic field. BrahMos 2. This K is for Kalam. It is under making. Mission Divyastra we discussed, no? What is Mission Divyastra? MIRV technology. So of Agni 5. Pralay missile is done. So we finished one more small part. Now we'll move into AI centers of excellence. So government had told us ki it will establish AI centers of excellence. What is the catchy aspect? Because it is as part of the vision make AI in India, make AI work for India. Okay, there is this mission, make AI in India, make AI work for India. Okay. Now, what are these centers of excellence and where are these established? So AI center of excellence, one is established in, healthcare ke oka center of excellence is established in IIT Delhi and AIIMS. Okay. So Delhi lone AIIMS, IIT Delhi, akkadne health mida. It is easy to remember, no? AIIMS is in Delhi. Next is agriculture. Agriculture, IIT Ropar. Okay. Ropar, I think, is in Himachal Pradesh. Oh, sorry, Punjab. Yeah, Punjab. IIT Ropar, agriculture. Then sustainable cities, IIT Kanpur. Okay. UP. You see, sustainable cities is in UP. Agriculture, Punjab. Obviously, Punjab is epicenter for all the agricultural activities, right? Because it was a kind of football of India at one point. So agriculture, Ropar. Sustainable cities, Kanpur. Healthcare, Delhi. Now, what is a center of excellence? So center of excellence is a specialized hub that brings together research, innovation, industry. So industry, academia collaboration aitadi. And the focus is on knowledge exchange, training professionals, interdisciplinary research. Okay, knowledge exchange, training professionals, and interdisciplinary research. See, now we'll move to another topic, quantum satellites. Okay, so note, Google's quantum computer is called Sycamore. Okay, it has achieved quantum supremacy 2 years back. Now there's a chip called Willow, which is there in the news. It allows many complex tasks to complete just in 5 minutes. See, this Willow chip is a quantum computer chip. A traditional computer will take 10,000 years to solve a particular problem. This Willow chip can solve in 5 minutes. Okay. But you have to understand the limitation of quantum computers also. Quantum computers cannot be used to do regular daily calculations. It cannot be used as a calculator, but they're good with simulation. So there are few tasks which you can do with quantum computers better. But even to operate a quantum computer, you need a normal computer. You understand that, right? So Willow is the chip. Computer peru Sycamore. Google, these are quantum computers. Now, what are quantum satellites? So background. National Quantum Mission. National Quantum Mission is a mission by Government of India, which is giving 6,000 crores for next 6 or 8 years. To make quantum technology affordable and scalable. We've discussed that there are 4 thematic hubs, no? Quantum communication, quantum metrology and sensing, quantum computing, and quantum development. Metrology sensing, and there's the other one called quantum. I don't know. Let's check.
Material.
Materials. Yeah, it's on materials. Yeah, my bad. So quantum materials. Thank you. Yeah, materials and devices. Yeah, quantum materials and devices. So now when we talk about quantum satellites, we are planning to launch within 2 to 3 years. Okay, so India is planning to launch a quantum satellite in 2 to 3 years. So it will basically be a communication satellite that will use quantum science for security. As I told you, quantum entanglement can be used to ensure there is a secure communication channel. Okay, quantum entanglement can be used to ensure secure communication channel, and thereby we want to use this quantum entanglement to have secure communications and satellite level communications. Okay. So for security, and there is also different protocols. Okay, prepare and measure protocol. These so basically we want to launch a quantum satellite which will enable safe communication. Okay, secure communication which no one can intercept. If they intercept, the entanglement law, the state changes, and we will get to know, and everything will be destroyed. I mean, the communication channel will be destroyed. Okay, I mean, although we can restart again, but the thing is, we will get to know if someone is intercepting, and they cannot intercept. See, in quantum computing, what happens is the data is not stored in midway. The data is created here, and it is recreated there. So once you give the data, it's recreated there. So the I mean, communication channel cannot be intercepted. And there was a news about nano bubbles. So Ministry of Environment, Forest Science and Climate Change has used this for Delhi zoo water, okay, to clean Delhi zoo water. So what are nano bubbles? So whenever you see nano bubbles, you understand that they can be used in water filtration. Okay, they are 70 to 120 nanometer bubbles. I mean, with diameter of 70 to 120 nanometers. They have a strong negative charge which attracts and breaks down impurities. Simple exam ke nano bubbles are used for water filtration. Okay, nano bubbles are used for water filtration. That is something you should know. Then nano bubbles will increase oxygen levels. Okay, will increase oxygen levels. And what happens if you increase oxygen levels? This aerobic bacteria inside will break down organic matter fast. For example, our river's health is seen by measuring its dissolved oxygen inside. Okay, Yamuna, after it passes Delhi, the dissolved oxygen is 0. It's not a river anymore, it's a nala. I'm not saying this, Sunita Narayan says it. Okay, she's a famous environmentalist. So dissolved oxygen is the measure of oxygen inside. I'm not talking about BOD, COD. BOD is different. Biological oxygen demand is different. Dissolved oxygen is different. Just know one particular point. Dissolved oxygen, ekkuunte, it is good. It is pure. Okay. So nano bubbles increase dissolved oxygen in a particular water or in a particular tanker or container. So nano bubbles are used in water filtration, right? Water filtration. How do they work? They have a strong negative charge which attract, I mean, what do you call, which attract and break down impurities. Okay. This is in water filtration and treatment. In agriculture, you can use these nano bubbles to give your plants more oxygen enriched water. It can be used in aquaculture where you don't need frequent filtrations of water. Aquaculture. Industrial cleaning, it can be used there. It can be used in your blood also, to deliver drugs. For example, nano bubbles. Bubble ante enti dan lopal some gas untadi. Right. So if you have a drug in form of a gas, you can deliver it. I mean, any liquid local bubbles form. Nano bubbles are very small bubbles. You won't even see it with your eyes. So you can. There is potential for it to be used in drug delivery. Okay, drug delivery. That is something you should know. And then another topic here, Dharini. IIT Madras researchers have unveiled Dharini, a detailed 3D map of 5 developing baby brains from second trimester. So it explains the rapid growth during critical stage. So Dharini is a very unique, brain map created by IIT Madras researchers on 5 brain-dead babies, I think. And it is one of the first maps of infant brains which is available open source. So although there are some brain maps, but they're not available for open source, but these people have put it in public. Okay, this is free to access map and largest and only one capturing the developing brain. Okay, at such an early stage. So this is one of the very unique researches because no research has focused on developing brain like the ones focused on Dharini. Okay, Dharini ante 3D brain map by IIT Madras researchers. Okay, it can help detect possible brain disorders like autism. Additionally, the findings could shed light on the changes in adult brain which are linked to mental health. So if you know the development of the brain, then you can see that how your mental health is being affected. Defects ఏమైనా ఉన్నాయా చిన్నప్పటి నుంచి brain map. So the only other publicly available brain atlas capturing was adult woman from USA, Allen Institute. So there are only two major brain maps. Inkokati US lo undi, India, Dharani. Okay. You see, researchers from IIT Madras used brains of 5 stillborns. Okay, these are stillbirths. Okay, in second trimester, 14th week, 17th week, 21st week, 22nd week, 24th week of pregnancy, stillbirth అయిపోతే then they captured when they took the babies, since they're dead anyway, they used the brains to make a map. The brains were frozen and thinly sliced. Brain this is they've sliced it, they mapped everything, and they made our atlas. These thin transparent slices were then stained microscopically and imaged in extreme detail. The digitized images were put together in a 3D map. ఇట్లా layers లా కట్ చేసి ఒక్కొక్క ఫోటో తీసి, ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఐ కట్ దిస్ లేయర్ ఫోటో, నెక్స్ట్ పైన లేయర్ ఫోటో, స్లోగా అన్ని ఫోటోస్ ని పెడితే ఒక 3D మ్యాప్ వస్తుంది. లేయర్ బై లేయర్ ఫోటోస్ ని పెడితే వాట్ ఇస్ 3D? మెనీ 2D లేయర్స్ ఫార్మ్ టుగెదర్, 3D ప్రింటింగ్ లాగా అనుకోండి. అండ్ ఆఫరింగ్ అ రేర్ ఇన్సైట్ ఇంటూ ఇన్సైట్స్ ఆఫ్ ఫీటల్ బ్రెయిన్. ఓకే, జస్ట్ నో దట్. అండ్ ఫ్రాంటియర్ టెక్నాలజీ ల్యాబ్స్ ఎందుకంటే వీళ్ళు వాళ్ళు చనిపోయారు, కానీ 14 ట్రైమెస్టర్స్ లో ఒకటి చనిపోతాడు, 1 బ్రెయిన్ తీసుకున్నారు. 17 వీక్ లో ఒకటి చచ్చిపోతాడు, అంటే 14th వీక్, 17th వీక్, 21st వీక్. బ్రెయిన్ ఎట్లా చేంజ్ అవుతుంది మనకు తెలియదు కదా, బికాస్ బేబీ ఇస్ ఇన్ సైడ్ ది స్టమక్. సో నౌ యూ హ్యావ్ ఆల్ దీస్ డిఫరెంట్ డెడ్ పీపుల్ ఆఫ్ డిఫరెంట్ ఏజెస్. సో ఒక్కొక్కరు తీసుకొని ఇట్లా డెవలప్ అవుతుంది బ్రెయిన్. ఈ పార్ట్ ఇప్పుడు డెవలప్ అయింది, ఈ పార్ట్ ఇప్పుడు డెవలప్ అయింది, అది. సో డెవలపింగ్ బ్రెయిన్ అండర్స్టాండ్ చేయడానికి ఇది ఇంపార్టెంట్. ఓకే, Atal Innovation Mission, again by Niti Aayog and Meta. Facebook is in collaboration with Atal Innovation Mission. Okay, announced the launch of Frontier Technology Labs. Okay, Atal Tinkering Labs are there in a lot of schools, but Meta and AIM, that is Atal Innovation Mission, together under Niti Aayog and Meta came together and they're forming Frontier Technology Labs. Why? To democratize future technologies and empower youth to innovate. What are frontier technologies? Which are advanced technologies are called frontier technologies. Frontier FTLs are advanced versions of ATLs. ATLs ante Atal Tinkering Labs. These Atal Tinkering Labs ni inka upgrade cheste frontier labs aithayi. They aim to equip students with state of the art infrastructure such as AI, augmented reality, virtual reality, blockchain, cyber security, robotics, 3D printing, IoT. Ivanni ippudu. Okay, this is funded by Meta with AIM as knowledge partners, that is Atal Innovation Mission as knowledge partners. Simple, Meta and Atal Innovation Missions came together. So where can you use this? Some example, or they can directly ask you what are frontier labs. Okay, yeah, just know frontier labs important. Okay, Atal Innovation Mission and Meta came together, they formed frontier labs. The labs will be managed by Meta's partner 1M 1B, that is 1 million for 1 billion, further facilitating the initiative's implementation and impact. So basically they want to create 1 million labs to impact 1 billion people, something like that. Okay, it aligns with the vision education to entrepreneurship initiative. So first you should have a vision education to entrepreneurship. Again, I don't know what exactly this is, but just know that it aligns with the mission. Then establishing FTLs aligns with Atal Innovation Mission's vision to create the culture of innovation. Okay, Atal Innovation Labs or Atal Innovation Mission etc. is to create culture of innovation. Ante culture is start kavali. And entrepreneurship in school Atal Tinkering Labs enti school lone entrepreneurship generate cheyochu ani. Then education to entrepreneurship initiative, this is by Meta, formerly Facebook, and Ministry of Education, Ministry of Skill Development also. They're together working. Okay, Facebook is working for entrepreneurship initiative. Yeah, that is done. Now there's an initiative, Sangam. It's a digital twin initiative. What is a digital twin? So the Sangam, that is digital twin initiative, is by Department of Telecommunication. This is an important statement. Why? This is not Department of Science. This is Department of Telecommunication. One, see, whenever I talk about digital twin, I talk about some kind of simulation. For example, I say there is Hyderabad, or there is this classroom. Okay, there is this building. If I make a digital twin of it, I'll design the very same building in computer. I can add people into this building. I can add people who walk here. I can simulate. I can add chairs. I can do everything. Now, if I want to test fire safety, I can test it there only. If I want to test how many people, capacity, etc., I can test there only. So digital twin initiative mein, if I want to make some changes, I'll first change in digital twin mission. So you can do different sort of simulations inside. So digital twin, I mean Sangam digital twin mission is by Department of Biotechnology. Sorry, not bio, telecommunications. It's a simulation. For example, there is a project called Virtual Singapore Project. It is a 3D platform which allows stakeholders to solve cities' complex problems. So Singapore city మొత్తం virtual ఉంటుంది. GTA San Andreas Vice City లో ఆడినట్టు ఆడొచ్చు పోయి. అయితే you can change things and test how things are working అని చెప్పేసి. Cities problems ఎట్లా solve చేయాలని ఉంటుంది. So that is Virtual Singapore Project. We can have Virtual Hyderabad Project also. Amaravati's digital twin is being created. Okay, Amaravati's digital twin is being created. Aim Sangam aim ఏంటి? To revolutionize the infrastructural planning. ఇప్పుడు ఎక్కడ టవర్ పెడితే అందరికి సిగ్నల్ పోతుంది టెస్ట్ చేయడానికి డిజిటల్ ట్విన్ మిషన్ వాడతారు. ఓకే, టు రెవల్యూషనైజ్ అంటే ఇప్పుడు ఇక్కడ సెల్ ఫోన్ టవర్ పెడితే ఎక్కడ వస్తుంది సిగ్నల్, ఎక్కడ దాకా వెళ్తుంది, టు రెవల్యూషనైజ్ ది ఇన్ఫ్రాస్ట్రక్చర్ ప్లానింగ్ బై ఇంటిగ్రేటింగ్ డిజిటల్ ట్విన్ మిషన్ విత్ ఐఓటి ఏఐ ఎంఎల్. సో ఇప్పుడు డిజిటల్ ట్విన్ చేసి వదిలేస్తే నడవదు. యూ హ్యావ్ టు హ్యావ్ సెన్సర్స్ ఇన్ రియల్ లైఫ్ టు మెజర్ దట్ దిస్ ఏరియా విల్ హ్యావ్ మోర్ ట్రాఫిక్, that area will have less traffic. Okay, so we have to integrate digital twin technology with IoT, AI and ML to understand. 2023 lo Survey of India, National Mapping Agency and Genesis joined hands to aid Smart Cities mission for a 3D digital twin program. So Government of India is also planning to make 3D digital twins with a company called Genesis for our Indian Smart Cities mission. Okay, ఇప్పుడు digital twin mission అంటే ఏంటి? It's a simulation of real world. Yeah, see, DeepSeek news lo undi, so they can ask you different AIs from India. AI Hanuman. Before we do that, do you know what is Web 3? Web 3.2. So Web has evolved from Web 1.2, 2 and 3.2. Web 1 ante when internet was there, I mean very initial days of internet, it was just static pages. People are writing something, you're seeing ante. No option to comment. Just information access cheyadaniki ante. Ekkado edo information undi, you're accessing it. Some paper there, some person is writing some book there. That is Web 1.0. Web 2.0 is when you can interact with them. For example, Facebook la likes, comments, shares. Okay, you can interact. You can create your own page. You can interact with your audience. You can post. Okay, you can like, you can dislike. There is some interaction. Web 3.0 is currently, I mean, last few years it has been prospering. Web 2.0 lo ఉన్న problems ni Web 3.0 solve చేస్తుంది. And what were the problems of Web 2.0? Although you can interact, do a lot of things, you have to do it via a medium. What was that medium? Facebook, Meta. So I could only do it via Facebook, Google, Gmail. I could only do it via Gmail. So these big companies, you know, Gmail, Meta, these were dominating the space. Okay, if you have to open a website, if it is not listed on Google, who will visit your website? No one would, right? Now Web 3 is a disruptive sort of revolution where now it is enabling, it is enabling you as a person to directly interact without any intermediaries. Web 3 and the first thing should come to your mind, no intermediaries. For example, how can you do that? So now a lot of people are making their own websites. Now, even though not on Google, they're having their own Telegram channels now. They're teaching directly, having their own apps now. So ఇప్పుడు further గా Google ni, but still they need some kind of phone pay key. You have to have some intermediary, but that is also now changing. People are directly getting their accounts of phone pay, money అక్కడ వెళ్తుంది. సో ఇంటర్మీడియరీస్ తగ్గిపోతున్నారు. ఫర్దర్ గా ఇంకా తగ్గాలి అంటే ఇప్పటికి కూడా ఈ గూగుల్ ఓన్లీ, గూగుల్లో లిస్ట్ అవ్వాలి నీ సైట్. సో ఇంకా తగ్గాలి అంటే there is something called as blockchain technology, and in this blockchain technology, if you integrate this blockchain technology into Web3, what will happen is you don't need any intermediaries to keep the records for you. For example, why do we need Google or Amazon as an intermediary? Just imagine Amazon nunchi you order, because you think that there will be a refund option. I can call to someone if my product is not delivered. I can complain somewhere. But what if we have blockchain? A blockchain, if you can add, what do you call? And if trust is on Amazon, but what if we can have a blockchain where you can directly add? Okay, if I order something, I'll directly add into it. Now I'll know my what do you call? In that blockchain, it is feeded ki Pani ordered this from this particular place. Now no one can change it. ఇప్పుడు నేను అమెజాన్ నుంచి ఎందుకు ఆర్డర్ చేస్తా అంటే ఇఫ్ ఐ ఆర్డర్ ఫ్రమ్ అ కంపెనీస్ నార్మల్ వెబ్సైట్ దే మైట్ డిలీట్ ఎవ్రీథింగ్ దే సే యూ డెంట్ ఆర్డర్ పైసలు ఇఫ్ దే స్కామ్ వాట్ విల్ హ్యాపెన్ no right gone. So but now if there is a blockchain, if it's added in the blockchain and if blockchain is already distributed, blockchain nunchi you cannot edit. We'll discuss the technology of blockchain later, but you cannot edit in the blockchain because it's with every single one. Now this blockchain I can show as a proof and I can go to law enforcing agencies, I can penalize him. Okay, so intermediaries ni completely తీసేయడానికి blockchain technology is being used. Kaadu, will be used. For example, there is a CBDC, central bank digital currency. You can using that you can pay one. Okay, although that is not picking up properly in wholesale market, it has to pick up. In retail market, it's not picking up. There's this thing called NDC, digital commerce, open market for ONDC, open network for digital commerce. And Zomato, Swiggy, you can still order food from ONDC. Amazon, Flipkart, ONDC you can order. Government is only creating a place where there is disintermediation. So Web3 ki whole idea is to disintermediate. Okay, disintermediate. And that is happening also. Now there are a lot of open source apps where you can go create your own app, have your own, these days Web3 there's a lot of coaching industries flourishing in Web3. Everyone is opening their own page, Telegram, doing things. Okay, because they don't need any intermediate now. This is Web3 revolution which is happening. To further revolutionize, we need to use AI and blockchain technology to completely eliminate these intermediaries. Because what happens is, as long as these intermediaries are there, for example, ippati kuda Play Store lone list avvali app, right? Play Store nunchi download chesukovali app. Adi kuda teeseste, if you have app on blockchain, APK, that means trusted ga download అయిపోతుంది. అంటే that no one can change. If it is inside the blockchain, no one can change that APK. Virus ఏం రాదు. Fake APKs download చేసే ఛాన్స్ ఉండదు. So if you have a blockchain technology which is more decentralized, then it will disintermediate. So Web3 ante adi, and UPSC has asked a question, and especially cryptocurrency kuda vachesindi ippudu. So you can directly pay. You don't even need what do you call central banks money also. Crypto money only you can have. This is also disintermediation. That is Web3 for you. Again, they asked once, they might ask again. So AI, DeepSeek came. What is, I have notes on DeepSeek, I think. So we'll finish DeepSeek first. But before we get into DeepSeek, there's something called all these GPTs. GPT full form cheppandi. Chat GPT. Predictive transformer. Okay. Text transformer. So GPT full form adi. Now GPTs are made on models called large language models. These are nothing but trained neural networks. Deep learning is a process which these people use. So what is a large language model? So large language model is used to design, large language models are designed to understand and generate human language. They understand human language and they generate human language also. This is also, NLP, that is natural language processing, is a part of large language model. Now, but you have to understand that every model is as good as its data. For example, DeepSeek, you know what is DeepSeek, right? These days, what happened was when DeepSeek was released, after roughly 1 or 2 months, it crossed the number of downloads than ChatGPT. ChatGPT కంటే ఎక్కువ మంది డౌన్లోడ్ చేసుకున్నారు. What happened? Nvidia stock tanked. Stock market లో AI companies అన్ని stocks పడిపోయినాయి. Why? Because China is now seeming to dominate the space, and it was not under DeepSeek. I cannot say it is superior than ChatGPT, but I can definitely tell you it's much more cheaper than ChatGPT, because ChatGPT has used billions of dollars to train its model, but this company has only used few millions of dollars. So takku paisalo it got almost the same level product. 1, 2, this is open source. DeepSeek is available and you can run it on your laptop. ChatGPT you cannot. Even if it is open source, you cannot, because it requires huge amount of processing. Okay, because ChatGPT has some thousands of parameters. DeepSeek has only few parameters. Okay, so చిన్న chips లో ChatGPT వర్కే అవ్వదు. For example, I'll give you an example. If let's say my name is so and so, ChatGPT will read my name is so and so. DeepSeek will read whole sentence at once. So I mean, the way DeepSeek works is, I mean, this is called distilled language model. Okay, there's this word called distilled language model. What is distillation? Distillation is when you heat a particular, what do you call, a chemical, so that you eliminate impurities slowly. Fractional distillation. What happens? Paina, ante you convert liquid into vapor to filter cheyadam. Okay, distillation is filtering. So this is called distilled language model. So when you download, DeepSeek is again open source model only, no? So if you download it in your laptop and if you ask about Tiananmen Square incident, what happened on June 4th, Tiananmen Square mein, then it will actually tell you all the controversies. But online, if you run it, no, it won't tell you. Tiananmen Square ante, that is beyond my scope anustadi, because they don't want to expose China, right? And China gurinchi negative game raadu. Enduku? The data is trained like that. Okay, so any model is as good at its data. Second thing, keep these models, again, data ekkada nunchi vastadi data. There's always a controversy about data getting from New York Times, itla pedda journals. వీళ్ళందరూ మా డేటా నుంచి మీ ట్రైన్ చేసుకొని యువర్ ప్రాఫిటీరింగ్ అంటారు. Again, but that is also debatable, because every knowledge, I mean, every subsequent scientific discovery is built on the previous knowledge, right? Calculus lekunda you can't do anything now. Can he say Newton say ki ha calculus ledu ani? No, right? So there's also a huge debate, ethical debate, moral debate. We'll keep those things aside, they're not asked for prelims. But just know that if data is biased, your model will be biased. And that is why once initially ChatGPT, someone asked ki classify humans into good or bad. It gave you a code ki if they are white, good; if they are dark, bad ani. Why? The data which came was from, the data which was fed was trained on Twitter, not US. Twitter, again, what happens in this social media thing is, people who are completely, irrational, shouting, anger spreads more in social media, no? So all the data which racial biases people had on their Twitter profiles was studied by this ChatGPT, and it's now giving racially biased answers. Okay, so China's DeepSeek did with smaller chips, just $6 million, not billions. It's open source. Now people can build on DeepSeek. It doesn't need massive data centers to operate. It is comparable to ChatGPT, and it competes with the paid models. Okay, I'm not saying it is better. It is comparable. See, what happens is, when I say, you cannot simply say one model is better than others, because few tasks when given to ChatGPT, it performs better. Few tasks when given to DeepSeek, it performs better. So task but it depends. Okay, but if you compare all the different level tasks, ChatGPT is still better, right? So distilled language model low, what happens like? So DeepSeek has used ChatGPT to train it. So large language models were used to train this model. So it's like already an expert is training you, something like that. So ChatGPT kaadu, Anthropic, ivanni models ni vaadi DeepSeek took training. So DeepSeek used multiple LLMs, including open source ones, to train itself. That you have to understand, and that's why it is robust and adaptable. So answer question em raavachu, large language models, distilled language models. Okay, and we came here because AI Hanuman, okay, the Indic AI model. So Bharat GPT unveils AI Hanuman, the Indic AI model. Hanuman is a series of large language models that can respond in 11 Indian languages, such as Hindi, Tamil, and Marathi. Okay, it is a multimodal AI tool which can generate text, speech, videos. See, can ChatGPT generate videos? Paid version can generate text, not videos. Paid version text nahi, images, not videos. Images ki, sorry, videos ki you have Sora. Sora is also by OpenAI. OpenAI is the parent company of ChatGPT. One of the products of OpenAI is ChatGPT. Sora is also by OpenAI. Okay. So, but your Bharat, I mean, Hanuman AI can give you text, speech, and videos. Okay. It is developed by Bharat GPT Group, backed by Reliance Industries. Okay. India, we need this Reliance Industries. Then Department of S&T in collaboration with Sita Mahalakshmi Healthcare. Not important. But just know that Bharat GPT would exist. And when you say it is multimodal AI tool, it means it can generate text, speech, and videos in multiple Indian languages. Okay. Hanuman has been designed to work in 4 fields: healthcare, governance, finance, and education. So, only 4 fields. It is the first customized versions of VisiGPT, which uses AI models. Again, just don't worry about this. Some healthcare. Example name the large language models, Bharat GPT, Hanuman AI, multimodal, Indian languages, maximum ade. Bharat GPT is a revolutionary innovation by CoreOver.ai. CoreOver.ai is world's first human-centric conversational AI platform. Human-centric conversation. And this is not in general conversation. Humans are always in center of this conversation. But for exam, you should know that OpenAI is ChatGPT. Okay. Then Bharat GPT is Hanuman. 1. Next, Google is Gemini. Previously it was called Bard. It's not Bard now, it's Gemini. Microsoft, Copilot. Okay, Microsoft is a Copilot. Just know these. See, if they can ask you vaccines, they can ask you this also. Huh? చేసినప్పుడు చూద్దాం. ఇది ఉంది, యా, దానికంటే ముందే 23 లోనే ఉంది. ఓకే, అంటారు, అది వచ్చిన తర్వాత చూద్దాం. ఓకే, only Indian indigenous generative AI platform. Bharat GPT, this is the only indigenous AI generative platform. Okay. Now, few other things you have to understand. What are large language models? These are powerful AI tools designed to generate human-like language. These models have extensive number of parameters, enabling them to understand the context, grammar, semantics in the text. They are widely used in tasks such as natural language understanding, translation, text generation, sentiment analysis also. Okay, got it? LLMs clear kada? Now we look at something called as a metamaterial. Now, what is a metamaterial? A metamaterial is any artificial and superior material. Okay, any artificial and superior material. For example, natural property and meta is better material. Okay, so there is a metamaterial called Analaksha by IIT Kanpur. Analaksha can absorb microwaves. Now imagine radars use microwaves. If you have Analaksha material on your aircraft, it will absorb microwaves kada. So stealth ostadi kada mana aircraft ki. Stealth is better for warfare, right? So metamaterials are superior materials. Okay, metamaterials are superior materials. Analaksha is by IIT Kanpur. It can absorb microwaves. Now it's like a cloak. Harry Potter lo cloak untundi, like invisibility cloak. It's a cloaking system. Just know that metamaterials and superior materials for now. Now, small modular reactors. We already discussed. In general, what are small modular reactors? Any nuclear reactor which generates power from 30 megawatts to 300 megawatts, they are small modular reactors. SMRs are advanced reactors which have power capacity up to 300 megawatts. Okay. According to International Atomic Energy Agency, more than 70 SMR concepts are currently under development in 18 countries. Okay, the different concepts of SMRs ఉంటాయి. See, the biggest, whenever I say modular, what do you mean? అంటే నేను different parts ని I can create separately and then join them like a puzzle and make a reactor. ఓకే, జస్ట్ ఫిట్టింగ్ చేయాలి. ఇప్పుడు ఐకియా నుంచి మనకు ఫర్నిచర్ ఇస్తారు కదా, అట్లనే. సో వెన్ ఐ సే మాడ్యులర్ డిజైన్, ఐ మీన్ యూ కెన్ ఫిట్ దీస్ థింగ్స్, ఓకే, బై మ్యానుఫ్యాక్చరింగ్ ఇట్ సపరేట్లీ. సో స్మాల్ మాడ్యులర్ రియాక్టర్స్ క్యాన్ బి మ్యానుఫ్యాక్చర్ సపరేట్లీ అండ్ క్యాన్ బి ఇన్స్టాల్డ్ ఇట్ వెరీ, ఐ మీన్ ఫర్ ఎగ్జాంపుల్ ఒక వెరీ స్మాల్ మాడ్యులర్ రియాక్టర్ క్యాన్ బి ఇన్స్టాల్డ్ ఇన్ ఒక బిగ్ గేటెడ్ కమ్యూనిటీ. ఇట్ క్యాన్ బి యూస్ టు యునో లైక్ గివ్ పవర్ టు దట్ గేటెడ్ కమ్యూనిటీ. చాలా రోజులు వస్తుంది ఆ పవర్, రైట్? Advantage of small modular reactors is that they have smaller footprint based on locations are not suited. So wherever, if let's say if you have to establish a large nuclear plant, okay, by the way, where are all the nuclear plants in India? Just tell me all the nuclear plants. First, Kalpakkam, Kalpakkam, then Kundankulam, Tamil Nadu, ఆ తర్వాత రాజస్థాన్లో రావత్ భట్ రాజస్థాన్, మహారాష్ట్రలో తారాపూర్, గుజరాత్లో కాక్రాపర్. You have to know all of these things. Okay, then what else did we miss? Narora, UP. Major give kada. We missed one or two, but that's okay. This is fine. Rawat Bhat, Kakrapur, Tarapur, Kalpakkam, Kundankulam, Narora. Okay? Yeah. Now, you see, these small modular reactors, if you have to establish a large reactor, you need some kind of water there. Okay, a lot of water there. But small modular reactors, you can put it in a lot of places. More locations which are not suitable for large nuclear power plants, you can use them small modular reactor. Okay, then they're affordable. Prefabricated units, అంటే ముందే ఎక్కడో fabricate చేసి you can just install here and can be manufactured and shipped or installed on site, right? కానీ large nuclear reactor అక్కడనే కట్టాలి, right? Small nuclear reactor వేరే దగ్గర కట్టి తేవచ్చు. Savings, they offer more savings in terms of cost and construction time, but initial cost is huge. Okay, initial cost is huge. Now IAEA, that is International Atomic Energy Agency, has established the platform on SMRs and their applicability. And a one-stop shop for all the countries to coordinate and support. So IAEA has established a platform on SMRs. So అందరికి టెక్నాలజీ చేయడానికి ఇంటర్నేషనల్ అటామిక్ ఎనర్జీ ఏజెన్సీ SMRs ని పెడుతుంది. Okay, there are micro reactors, small modular reactors, conventional nuclear reactors. Micro reactors అంటే 10 megawatts కంటే తక్కువ, small modular and up till 300. See, refueling చూస్తే micro reactors ki it can go on to 10 years, 15 years without refueling. Small modular reactors ki 3 to 7 years without refueling. Okay, but conventional reactor ki every 1 to 2 years you have to refuel. Okay, conventional reactor ki 1 to 2 years you have to refuel. This is something you should know. Now just give me a minute, I'll get my charger. Keep reading this something now. Wait. Okay. Small modular reactors may SMRs have capacity up to 300, we know. See, they can produce large amount of low carbon density electricity. So that's why you have to understand that they have less carbon footprint. SMRs have less carbon footprint. Okay. Then see, micro reactors ante up to 10 megawatts. Okay. Then see, smaller than traditional nuclear reactors, modular, pre-assembled untai, and quick installation. Uses nuclear fission only. Same technology, fission technology. Advantages: power for all, grid stability. What happens is grid often depends. If you are having a grid which is depending upon solar, then there's a problem. If the weather is inclement under rainy weather, cloudy weather, what will happen? Solar panels cannot produce enough. So grid stable avvadaniki, you can use them, right, to support intermittent renewable energy. Okay. Climate change mitigation. Why? It is having lesser carbon footprint. Safety. These SMRs, they cannot have this core melting. They won't have this core melting, and it's easy to contain also. If it goes out of control, chala nuclear material unte simple ga aa area nanta seize chesthe inta chuttupakkala concrete posesthe chalu ayipotadi. But if it's a big reactor, it's a huge problem. For example, Chernobyl nuclear disaster, chuttupakkala unna village anni ellipoyinayi akkadi nunchi. Okay. Pripyat river daggara. So environmental friendly, uses 30 to 60% less water, lesser carbon footprint, less water also. Okay. Then land use efficiency. It can repurpose retiring and coal power stations. For example, look up old coal power station. There you go, establish these reactors. No. Deployment flexibility. Small modular reactor units allow scalability based on the need. That means if the need has increased, simply you can put another small reactor there, or connect the other small reactor, or increase the scale, increase the number of fuel. So scalable anamata. You can quickly, for example, if you've established a 100 megawatt unit, దాన్ని కొన్ని చేంజెస్ చేసేసి 200 కూడా చేయొచ్చు ఫ్యూచర్ లో ఇంక్రీజ్ అయితే. ఓకే. సో స్కేలబిలిటీ. కానీ అట్లా కాదు, ఫర్ లార్జ్ రియాక్టర్స్ 700 megawatts తో పెడితే అంతే ఉంటుంది అది. ఓకే. అండ్ లెస్ ఫ్రీక్వెంట్ రీఫ్యూలింగ్. దిస్ క్యాన్ బి ఎ క్వశ్చన్. లెస్ ఫ్రీక్వెంట్ రీఫ్యూలింగ్ 3 to 7 years compared to 1 to 2 years for large reactors or conventional reactors. Concerns enti? High upfront cost. To set up initially, it will require a lot of cost. Okay. And mass production ki ekwa kavali. I mean, it will lead to high electricity prices. Then you have 30% more radioactive waste. This is also important. It produces 30% more radioactive waste. Ekwa produces. Small modular reactors have less carbon footprint, but more waste. More waste. Okay. Then other challenges: fuel options limited. And if, for example, only some can be used in fuel options. Okay. Uncertainty, again, reliability is not tested yet. And if you have a lot of small modular reactors working, only then you can test the reliability kada. Enta varaku reliable, eppudu ayipote pani cheyadam idi telvadu. Environmental impact, we don't know, we've not tested. Security risk is always there. Term nuclear backpacks. Akkada nuclear backpacks ani. So if terrorists come and attack, take over. So nuclear backpacks untai, and way ahead, basically we have to work on it with better technology, more safety, security, all these things. And yeah, micro reactors. Enti micro reactors ante 10, roughly 10 megawatts. Okay. So these are very small nuclear reactors which are much safer, more portable, more scalable. Okay. Essentially, one small micro reactor placed in Lakshadweep could take care of all the power of island. Micro reactors are anta powerful. I mean, chinna reactors. Then how safe are these micro reactors? I mean, power capacity 10 to 20 untadi kabatti they're pretty safe only. Thus the radioactive inventory in the reactor is very less. The conventional large reactors require large water to cool and operationalize from accidents. Micro reactors fuel ante chinna fuel e untu koncham fuel e untadi kabatti the heat decay is lesser. Okay. Air can be used as heat sink. Ekko water avasaram padadu. Also, micro reactors are inherently safe. They can be placed near public areas as their design eliminates the severe accidents. Poor meltdowns above. Okay. Are micro reactors easy to use? Yes. How frequently you have to refuel? much more time is needed. 10 to 15 years is needed. This is important. Higher temperature order of 800 degrees Celsius. More can be attained in microreactors. Okay. So in contrast, large nuclear reactors. So you will think there is more temperature. Okay. Important point is large nuclear reactors. So there is more temperature. Ankuntam. And no. Small nuclear reactors. So there is more temperature. You observe this. 480 is in conventionally large reactors. 800 is in microreactors. Okay. So this can be a question, no? There is a lot of temperature in microreactors compared to conventional big reactors. So పెద్ద reactors లో తక్కువ temperature ఉంటుంది. First thing. Big reactors have lesser temperature. Yeah, perfect. So next, higher temperature is very advantageous. Why? For target applications such as hydrogen produce చేయొచ్చు. Heating తోని, desalination plants. So the heat produced there, బయట ఇంకా వేరే వాడుకోవచ్చు దాంతోని. Okay. So how will India manage the raw materials? Again, uranium, ఇవన్నీ low enriched uranium కావాలి, thorium కూడా వాడచ్చు. So there are a lot of things, not important. Just know this point also. Global Innovation Index 2024 lo India ranks 39th. Global Innovation Index 2024, India ranks 39th. Then just know that in Network Readiness Index, India is 49th. Network Readiness Index, India is 49th. Then you have, there are 4 thematic hubs for materials and devices. Even we missed. So 1 minute. How cost effective are micro reactors? This can be a question, right? So you see, large reactors will cost around 17 crores, because 17 crores per megawatt, and construction cost matrame. And micro reactors cost around 20 crores per megawatt. That means micro reactors need more upfront cost. But if you అంటే obviously ఇప్పుడు if you are building a huge big reactor, no, economies of అంటే పెద్ద ఫ్యాక్టరీలో తక్కువకే అయితే ప్రొడ్యూస్. So if you are building a big reactor, the cost will be less only. However, the difference can be reduced between microreactor and conventional reactor if you use it for more years. So a microreactor you can use it for 10 years, no, 10-15 years continuously. In addition, initial investment in microreactors is lower, thereby attracting many investors in early deployment. ఇప్పుడు 700 megawatts into 17 crores చేస్తే ఎక్కువ, కానీ 20 megawatts into 20 crores చేస్తే ఎంత? 400 crores, right? So which is better? With microreactors. And itla, you think about this. Also, microreactors can be fabricated and connected with grid within 2 to 3 years. Thus, early return on investments వచ్చేస్తాయి. Okay. So again, micro reactors ante 10 megawatts, small modular reactors ante 30 to 300 megawatts. These can be questions. And National Quantum Mission, we saw, right? 8 years ki 6,000 crores is the budget. What are the 4 thematic hubs? Quantum computing, IISc Bangalore, quantum communication, IIT Madras, and Department of Telecommunication. Then quantum sensing and metrology, it is science of measurements, metrology, IIT Bombay, materials and devices, IIT Delhi. Okay. Now, there's something called as National Supercomputing Mission. Okay. This can also be in the news, and this has been in the news. Now, this mission is jointly implemented by MITI. MITI ante Ministry of Electronics and IT. MITI is Ministry of Electronics and IT and Department of Science and Technology. So, A2 ministries chestunayi, Electronics and Science and Technology. Ministry kaadu, department. Has created 27 petaflop 27, this is important, 27 petaflop of computing capacity at 28 sites across the country. And total anni supercomputing we add cheste, we have how much capacity? 27 petaflops. Okay, total anni kalupte, not at one place. In the year 2024, National Supercomputing Mission commissioned 5 supercomputing systems developed, indigenously developed based on indigenously developed Rudra server, Rudram radar. Okay, just know that mana server, Rudra server, which was indigenously developed. Dantlo 2024 alone we had 5 different supercomputers were launched. Okay. Now, among these, 3 have been dedicated to nation by Honorable PM The system at Inter-University Acceleration Center, IUAC, is the biggest among them with a total computing power of 3 petaflops. ఇక్కడ ఢిల్లీలో IUAC లో ఈ 5 లో టాప్ ది ఇక్కడే ఉంది. The other two notable systems have been dedicated the capacity of 1 petaflop and 833 petaflop functioning at NCRA Pune and SN Bose Institute of Kolkata. Not important. In addition, 5 petaflop of computing has been added with exceeding infra. So ఎంత మనది currently petaflops, and we are planning to have 45 extra petaflops. Okay, so no, sorry, the 27 petaflops 27 sites by 23, thereby national supercomputing mission so far currently 32 petaflops station. Okay, just have number is not important, 30 plus is important ante. Okay, yeah, in the coming calendar year 45 petaflops ni we will add అని చెప్పేసి చెప్తున్నారు అంతే. It's envisaged. Just know supercomputers are measured in petaflops. Cumulatively ఇండియాలో 32 petaflops ఉంది అంతా కలిపితే, అన్ని కంప్యూటింగ్ కలిపితే. జనరల్ గా ఒక కంప్యూటర్ కి అంటే హైయెస్ట్ సూపర్ కంప్యూటర్ ఏంటి 5 petaflops 8 petaflops ఇంతే ఉంటాయి. అంటే మన దగ్గర యుఎస్ లో అక్కడిక్కడ ఎక్కువ. ఓకే, ట్రై. వాట్ ఇస్ ట్రై? టెలికాం రెగ్యులేటరీ అథారిటీ ఆఫ్ ఇండియా. ఇట్ ఈస్ నౌ యూజింగ్ బ్లాక్ చైన్. What is blockchain? If someone asks you what is a blockchain, what will you tell? It is a distributed ledger. It is a distributed ledger. What is this distributed ledger? What is ledger? Ledger ante khata, very right? This amount of money was sent to this amount of people. Okay, kind of khata. Okay, you have different transactions untai kada khata la. So if all these khata, if one khata is there and andarki panchutayeno, distributed ledger. అయితే ఈ ఒక్క ఖాతాలో మళ్ళీ మార్చాలంటే అందరి దగ్గరికి పోయి మార్చాలి, అట్లా చేయలేము. సో బ్లాక్ చైన్ ఇస్ అ డిస్ట్రిబ్యూటెడ్ లెడ్జర్. నౌ ట్రై ఈస్ యూజింగ్ ఇట్ టు రెడ్యూస్ స్పామ్ కాల్స్ అండ్ మెసేజెస్. ఓకే, ట్రై ఇస్ నౌ యూజింగ్ ఇట్ టు రెడ్యూస్ స్పామ్ కాల్స్ అండ్ మెసేజెస్. ఎట్లయితుందంటే వన్స్ ఇఫ్ దిస్ caller is doing, if this number say you got spam call, if you report it, it will be added in blockchain. This blockchain is distributed so much that everyone will see it, and అది బ్లాక్ చైన్ లో ఉండిపోతుంది, ఇంకా మళ్ళీ ఆ డేటాబేస్ నుంచి బయటికి రాదు. సో అట్లా బ్లాక్ చైన్ ఆఫ్ వాట్ కాల్ స్కామ్ కాల్స్ అన్ని వేస్తే పీపుల్ క్యాన్ ఫిగర్ అవుట్, అంటే కంపెనీస్ క్యాన్ టెల్ యూ ఇమీడియట్లీకి ఆ కాల్ వచ్చే ముందు స్పామ్ కాల్ అని, లేదా ఆటోమేటిక్ బ్లాక్ కూడా చేయొచ్చు. అది రైట్. దట్ ఈస్ ట్రై ఇస్ యూజింగ్ బ్లాక్ చైన్ టు డూ దట్. సో దిస్ క్యాన్ బి అ క్వశ్చన్. దెన్ దేర్ సంథింగ్ కాల్డ్ ఎస్ క్రాస్పతి. వాట్ ఈస్ క్రాస్పతి ఆర్ మిక్సోపతి అని కూడా అంటారు. సో ఇన్ మహారాష్ట్ర రీసెంట్లీ homeopathic practitioners were allowed to prescribe allopathic drugs. Homeopathic practitioners were allowed to prescribe allopathic drugs. Generally doctors prescribe చేయాలి కదా, MBBS చదువుతారు ఎందుకు వాళ్ళు ఇది చేయడానికి. Now if you are giving some homeopathic practitioner వాట్ ఏదో బయాలజీ లేదా హోమియోపతిలో సింపుల్ కోర్స్ చేసుకొని if he goes, but Maharashtra government has said ki if they complete the registered homeopathic course from registered universities or registered institutes from our state, only then we'll allow it. ఇది ఇనంగానే immediately Indian Medical Association or Indian Medical Council was angry, saying ki what is this అనేసి. So but just know this term is in the news, crosspathy, and Supreme Court ఏమన్నదంటే if you allow non-medical practitioners, that is non-MBBS doctors, to give these kind of medicines, that is medical negligence. Okay, but can you really, do you really think there are enough doctors? No. So you have to have more and more courses which don't give you a doctor degree but can give you at least some expertise with respect to what do you call giving medicines. And who are the people who will take such kind of courses? Not you and me. Ayush practitioners will take. So our courses ni eventually Ayush has to be integrated. Even our national health policy 2017 also talks about integration of Ayush, but this integration has to be done in a way that every stakeholder is taken into confidence and the coursework is to be seen in public. వీడికి ఆ సర్టిఫికేట్ వస్తుందో అది పబ్లిక్ లో ఉండాలి. ఎవ్రీ 2-3 years ఒక ఎగ్జామ్ ఉండాలి, మళ్ళీ వీడు అది క్లియర్ చేస్తూ ఉండాలి. సర్టిఫికేషన్ ఇప్పుడు సాఫ్ట్వేర్ సర్టిఫికేషన్స్ ఎట్లయితే ఎవ్రీ 3 years కి మెడికల్ కోడింగ్ సర్టిఫికేషన్ చేయాల్సి వస్తుంది పీపుల్ కి. సో యూ హావ్ టు హ్యావ్ అ ప్రాసెస్ విచ్ ఇస్ మోర్ స్ట్రీమ్ లైన్. నాట్ అలవింగ్ దెమ్ ఇస్ నాట్ ది సొల్యూషన్. ఓకే, సో ఇప్పుడు గవర్నమెంట్ మొన్న అయింది అది. యా ఓకే, now few more things. Yeah, just 1-2 more topics. So there is this news on nanoplastics. Although the terminology is not important, but nanoplastics, the new study has showed that nanoplastics are spreading antimicrobial resistance. Okay, nanoplastics are spreading antimicrobial resistance. You see, antimicrobial resistance has been an important topic for UPSC because there has been a question once saying what is triclosan. Ante question ante triclosan enti ante options lo one of the options was toiletries. తెలిసిన వాళ్ళు పెట్టిర్రు తెలియని వాళ్ళు తెలియదు. But triclosan was in the news if you follow antimicrobial resistance. For example, if you watch some toothpaste, it is clearly written no triclosan అని రాసి ఉంటుంది, no fluoride అని రాసి ఉంటుంది. What is this అంటే triclosan was a chemical which was being used in toiletry products such as toothpaste, what do you call mouthwashes, etc. అయితే this just by brushing every single day you are getting antimicrobial resistance just by brushing every single day. So that's a problem, right? So triclosan is spreading antimicrobial resistance. Similarly, nanoplastics are spreading antimicrobial resistance. There can be a statement kada. So how are they doing it? So these are facilitating antimicrobial resistant genes or plasmids. Ante chudu, a bacteria will be resistant to antibiotic eppudu if it mutates a little. ఆ మ్యూటేట్ అంటే ఏంటి, కొన్ని ఒక వేరే జీన్ వస్తే ఇప్పుడు ఆ జీన్ మైక్రోప్లాస్టిక్స్ మీద స్టోర్ అయి ఉంటుంది. ఆ జీన్ ఈజ్ ఇన్ టర్మ్స్ ఆఫ్ ప్లాస్మిడ్. అయితే ఇదేమవుతుందంటే యూజింగ్ మైక్రోప్లాస్టిక్స్ దిస్ జీన్ ఈస్ గెటింగ్ ట్రాన్స్ఫర్ ఇన్ టు అదర్ బ్యాక్టీరియా. సో ఆల్రెడీ ఆ బ్యాక్టీరియా విచ్ ఇస్ ఆల్రెడీ యాంటీబయాటిక్ రెసిస్టెంట్ ఇది ట్రాన్స్ఫర్ చేస్తే ఈ మైక్రోప్లాస్టిక్ వల్ల ట్రాన్స్ఫర్ అయితే ఇట్ ఈస్ స్ప్రెడింగ్ యాంటీమైక్రోబియల్ రెసిస్టెన్స్. అండ్ WHO ప్రకారం యాంటీమైక్రోబియల్ రెసిస్టెన్స్ ఇస్ అమాంగ్ ది టాప్ 10 గ్లోబల్ థ్రెట్స్. బికాస్ ఏమవుతుందంటే if I don't take my antibiotics properly, inside me 5 days కోసంటే 4 days తీసుకున్నా అట్లా చాలా చేసినా అనుకో, నా లోపల ఒక బ్యాక్టీరియా తయారవుతుంది. దట్ బ్యాక్టీరియా విల్ బి రెసిస్టెంట్ టు అజిత్రోమైసిన్. నౌ ఇఫ్ ఐ స్ప్రెడ్ దట్ బ్యాక్టీరియా టు అదర్స్, వాడికి కూడా అజిత్రోమైసిన్ పనిచేయదు. వాడి ఫాల్టే లేదు ఇక్కడ. ఐ డిడ్ మిస్టేక్ బట్ హీఈస్ ఆల్సో గెటింగ్ అఫెక్టెడ్ కదా. సో యాంటీమైక్రోబియల్ రెసిస్టెన్స్ ఇస్ అ గ్లోబల్ థ్రెట్. So that's why UPSC is always asked questions on antimicrobial resistance. So you have to understand microplastics are spreading antimicrobial resistance. Yes or no? Yeah. Now how is it happening? It is by transferring genes. And these genes are stored on the microplastics and they're getting transferred. And this transferring is happening on various levels and we don't need so much of jargon. Transformation. And the bacteria takes a gene directly from environment. Direct microplastic bacteria is taking. Usually ఎట్లా అవుతుంది అంటే via outer membrane vesicles. You don't need all of this. Just know that, for example, polyethylene terephthalate, PET bottles, polyethylene terephthalate, PET bottles అంటాం కదా, అవి నార్మల్ ప్లాస్టిక్ బాటిల్స్ ఆర్ డిరైవ్డ్, వాట్ యు కాల్, బాటిల్స్ డిరైవ్డ్ నానో పార్టికల్స్. అంటే ఇప్పుడు ఆ దాని మైక్రోప్లాస్టిక్స్ దే ఇండ్యూస్ ఆక్సిడేటివ్ స్ట్రెస్ అండ్ ఓకే, డోంట్ వరీ అబౌట్ ఆల్ ఆఫ్ దిస్. సింపుల్ గా డైరెక్ట్ గా తీసుకుంటే ట్రాన్స్ఫర్మేషన్, ఆ బ్యాక్టీరియా ఇస్ గెటింగ్ ట్రాన్స్ఫార్మ్ బై టేకింగ్ జీన్ ఫ్రమ్ అవుట్ సైడ్. నెక్స్ట్ ట్రాన్స్డక్షన్, అంటే ఒక వైరస్ ఒక బ్యాక్టీరియా నుంచి ఇంకో బ్యాక్టీరియాకి ఇస్తుంది జీన్, అది ట్రాన్స్డక్షన్, డక్ట్. నెక్స్ట్ కాంజుగేషన్, when one bacteria is sexually mating with another bacteria, then this what do you call, transfer of gene is happening. Okay, అది కాంజుగేషన్. You don't need any three, అవసరమే లేదు. బట్ దీస్ ఆర్ ఆల్ ది పాసిబిలిటీస్ అని తెలుసుకోండి. వైరస్ నుంచి కూడా వస్తుంది జీన్, సెక్షువల్ కాంటాక్ట్ వల్ల వస్తుంది, డైరెక్ట్ ఎన్వైరన్మెంట్ నుంచి వస్తుంది. యా, నోట్, డ్యూ టు నానోప్లాస్టిక్ ఎక్స్పోజర్, beneficial gut bacteria can turn into reservoirs of antimicrobial gene, antimicrobial resistant genes. అంటే మన own gut bacteria can form a resource for all the antimicrobial genes. Okay, that is harmful. Okay, got it? Nanoparticles. Yeah, Subal 20 drones, not much important, but VTOL technology was asked before. VTOL ante vertical takeoff technology. Okay, vertical takeoff and landing, technology, helicopter laga. So there is a Subal drone, and drones, VTOL drones ante entante they can directly vertically take off. There are few drones which have to go like a plane. They look like a plane also. Haroop, Rustam, even drones, Indian drones, they go like a plane, small plane untai. But they're VTOL drones, just know that. Then you have So just know that a recent study has shown that extra chromosomal DNA, and DNA outside chromosomes, is present approximately 50% in approximately 50% of cancer types, and is important in tumor evolution and genetic heterogeneity. Ante extra chromosomal DNA ante DNA outside chromosomes, it is found in a lot of tumor cells, ante it is related to cancer. Okay, if there is a lot of extra chromosomal DNA, then you have, cancer cells lo ekkuva untadi, ekkuva extra chromosomal DNA. Okay, so ecDNA are circular fragments of DNA located outside the nucleus of cancer cells. So cancer cells lo, ante non healthy cell, cancer cell lo ekkuva extra chromosomal DNA untadi. First you know that. It is created. How is it created? It is created by DNA damage. The presence of extra chromosomal DNA is an indication that DNA is damaged. Okay, it is created by DNA damage and chromosomal rearrangements happening. Okay. Then now, factors like smoking, exposure to certain substances lead to DNA damage. Smoking actually leads to DNA damage. Okay, and this leads to formation of extra chromosomal DNA. Okay, that's it. You should know that. So now recently there's something called as neoantigens. Okay, neoantigens. Russia mRNA vaccine. I told you how mRNA vaccine works in the last class, right? So Russian mRNA vaccine is under development, which can be used for, which can be used to give, and a personalized vaccine can be designed for you. Okay, which can be personalized based on genetic analysis of each person. You know what is pharmacogenetics? Designing drugs for your genetic makeup. See, everyone will have different genetic makeup. So designing drugs for you. For example, skin low, what they do is biopsy, and they'll take a part of skin, they'll add some drugs, and we'll check if it's working, that drug is working or not, Anish. And they can do it with your stem cells also. They can take your stem cells and they can check how is this drug working or not. But it is extremely costly for you, that they have to do and give it to you. So pharmacogenetics ante finding the exact drug in exact dosage which is designed only for you. Okay, pharmacogenetics, and it is somewhere like designing drugs for genetic makeup. That is pharmacogenetics, and it's a field of science which deals with these kind of things. So pharmacogenetics is a field of science which deals with designing drugs for you. Now there is designer vaccines also, personalized vaccines. Nee genetics kosam mRNA vaccines తయారు చేయొచ్చు అంటున్నారు రష్యా వాళ్ళు. అయితే to identify mutations called neoantigens. Neoantigens are newly formed antigens that arise from mutations in cancer cells. That means, ఒకటి గుర్తుపెట్టుకోండి, cancer cells, I told you in CAR T-cell therapy also, cancer cells will have unique antigens on their surface. Cancer cells will have unique antigens on their surface. So using these unique antigens, you can design a vaccine. You can go with CAR T-cell therapy also. Now this vaccine you can design in such a way that imagine last topic of today, if this is a cancer cell, tumor cell, now there is a unique protein on this. Okay, there's a unique protein on this. Now you take this protein outside, now you what do you call, you make mRNA for this protein, and you try to give it to your body. Okay, now this will be produced, full produce. Somehow, I don't know how, but somehow there is a theory that your T cells will learn to fight with this protein. Now once your T cells have learned to fight with this protein, this very same T cells will go attack your cancer cells, and they will only clean the tumor. Okay, so these are neoantigens. అయితే neoantigens అంటే ఏంటంటే, I told you every tumor cell will have unique antigen, no? Those are called neoantigens, and newly created antigens. Because నీ నార్మల్ సెల్స్ మీద లేని యాంటిజెన్ నీ ట్యూమర్ సెల్స్ మీద ఎందుకు ఉంది? నియో అంటే న్యూ. I repeat, neoantigens are newly created antigens on tumors. Okay, neoantigens are newly created antigens on tumors. Okay, yeah. This makes them ideal target for cancer immunotherapy. Okay, అందుకే just know this fact, cancer immunotherapy is dependent on neoantigens. Okay, and yeah, so this is the recent news. So we were This is moon. So dark moon mida you'll find some dark spots, dark areas. Those spots are full of magma. Okay, they're generally called Maria, not important. They're full of magma. Anduk dark unnayi ante ikkada magma unde full. Aithe now and white part highlands antaru moon vi. Aithe we found out that these highlands are rich in silicon. If we can make that silicon into silicon carbide, for example, silicon carbide toni sandpaper cheyొచ్చు, rocket parts cheyొచ్చు. We can mine moon, and if we have a habitat there in future, దాంతోని buildings కూడా కట్టుకోవచ్చు. జస్ట్ నో మూన్ మీద సిలికాన్ ఉంది అంతే. ఆ రీసెర్చ్ వచ్చింది, మూన్ మీద సిలికాన్ ఉంది. సిలికాన్ అంటే మట్టి టైప్స్. ఓకే, ఎస్ इसका इसका yeah, S silicon. Okay, just know that. The key highlight of this budget, which we already discussed, 20,000 crores are given for 5 SMRs. And ఎప్పుడు దాకా చేస్తాం అనుకున్నాం? 33 ఎట్లా గుర్తుంటది? You have to remember 32 first. By 2031-32 they said we will triple our nuclear energy. 8.18 something undi, it will become 22 point something. Okay, అప్పటిలోపు 5 SMRs ని కూడా తెస్తాం. ఓకే, 2033 వరకు. అండ్ రీసెంట్ గా మన ప్రోటోటైప్ ఆఫ్ ఫాస్ట్ బ్రీడర్ రియాక్టర్ ఏమైంది? సోడియం ఫిల్ అయింది అందులో. జస్ట్ నో ఫాస్ట్ బ్రీడర్ రియాక్టర్స్ లో కూలెంట్ ఇస్ sodium. Okay, when we discuss nuclear reactors, we'll discuss. Yeah, so that's it for today. I hope the class was good.